So good afternoon everyone. How are you? Good. So yesterday we have seen introduction to geography. Online students, are you able to hear me? Everyone? So yesterday we have seen introduction to geography. We have seen about latitudes, longitudes. We have seen about universe. Okay. So have you guys? Okay, you didn't. Okay, so today you got all the notes. Yes. So please go and see the previous year questions. Okay, they are very important. Some 50-60 questions have been asked till date. Okay. So most probably out of those questions, they will not ask you many questions. Even if they ask new questions, they will be on the same line. They won't be on a different lines. Okay. So today, what we are going to do is geomorphology. Okay, we started geomorphology yesterday. So today we are going to see the geomorphological theories. Geomorphological theories are very important for your mains actually. But nowadays, if you see, UPSC is erasing the distinction between what is in the mains, what is in the prelims. So it is very important to see everything, okay, even for your prelims. So we will go through geomorphologic theories in brief, okay, not in too much detail, but we will just brush it up each and every theory, okay. So geomorphological theories, when geography as a discipline emerged, okay, there were so many questions. As yesterday we have seen that human beings are full of questions since the beginning. Okay, the Vedas, Upanishads, Bible, Quran, Gita, everything is talking about origin of universe, how universe formed, how everything is formed. So those questions are still there. When geography emerged as a scientific discipline, they tried to tackle these questions through scientific way. So what do you mean by scientific way? Scientific way means not assuming and presuming anything. Scientific way means going on the field, studying the particular phenomena, gathering the evidences, analyzing them in the laboratory, coming to the conclusion and publishing the research. Okay. So this is a scientific way, because now we cannot believe, no, because the period with Western countries which they have been to a dark ages. Okay, they have been haunted, people have been killed by just speaking the truth. Okay, so the period of enlightenment happened. In the period of enlightenment, what happened? New thinkers came. They denied all the religiosity, they denied church, they denied all the religious scriptures, and they said what is true is human experience. Okay, so based on that, these new disciplines came. So whatever discipline, that geography as we are seeing today is the outcome of period of enlightenment which happened in the Western sphere. Okay, so when this geography as a discipline formed, all the geographers, they used to come together, they used to discuss. Most of them were armchair thinkers. That means they did not have many instruments, many machines in their hands. Like today we have satellites and all those tools in our hand, we can go and we can do a lot of research based on that. So at that time, the only way or the most probable way for them to do the research is to think about something. Like we have seen about Immanuel Kant. So the fellow is everywhere. Okay, how he can be everywhere, including geography, mathematics, physics, philosophy, psychology, everywhere. Immanuel Kant is everywhere. So if he does research, you know, today even small research, if you want to do, it takes whole life. Now this fellow is everywhere because just thinking. Okay, so these theories of geography, they are all outcome of, most of the part of this theory is the outcome of thinking process, and some part is also experimental processes. Okay, so out of them, three important theories we are going to see. First is continental drift, second is plate tectonic, and then seafloor spread. Okay, so if you see these theories and how they started. Okay, so the first theory that we are going to see is of Alfred Wegener's continental drift. Okay, so initially, as these people did not have many instruments in their hand, they had to believe what do they see. So just looking at the ocean and looking at the land, it is clearly visibly distinct. Okay, ocean floor looks like made up of hard rock, very hard and very dense rock. Continental floor is made up of a little less denser rock. Okay, plus continental floor was looking very thick. oceanic floor was looking really thin. Okay, visibly it looks like continental floor is resting on the oceanic floor. If you see the photograph of continental and oceanic floor, visibly you will feel like that oceanic floor is going under the continental floor and continental floor is resting on the oceanic floor. Okay, so because of this type of visual understanding, okay, so they came with this theory and they came with the concept called as a continent. But what is the basis of origin of this theory? So initially these people wanted to know why particular place experiences different types of climate in a different periods of time. Let us say from last 3 billion years ago or 2 billion, from last 2 billion, this Delhi as a place is experiencing different types of climates. 1 billion year ago climate was different. 50 crores years ago climate was different. Okay, 10,000 years ago climate was different. So why this climate is different in a different phases of the time period? So either entire earth is undergoing climatic shift after a particular period of time. First logical reason is entire earth is undergoing a climatic shift particular period of time. Or second thing, climatic regions are remaining stable. Delhi is traveling from one place to another place. Only two things can happen. Okay, so the geographers, okay, including the famous Alfred Wegener, okay, so they came out with this hypothesis. So different places in the world are experiencing different types of climate in a different time period. So these are the two possibilities. Either earth is undergoing climatic shift after every successive consecutive time period, or a particular place is shifting itself from one climatic region to another climatic region after a particular period of time. So Alfred Wegener took this challenge of decoding this question. He said, for me, most logical thing is that earth is not undergoing the climatic shift, but a place, a particular location is changing its place from one region to another region. Okay, so he said, I am going to prove this with all the facts and results. So whatever the quest of Alfred Wegener and how did he proceed to search about this entire thing is known as continental drift theory. Okay, so continental drift theory, the objective was to explain major variations in the climate. Okay, so the basic question was how there are major variations in the climate. Okay, origin of mountains, origin of island arcs, okay, how continents and ocean basins were formed. So these were the different questions which they tried to find the answer. So Wegener as a scholar, he said, since I am going with the option 2, that a place is traveling, a particular landmass is traveling from one region to another region. So he has to prove that how this landmass is traveling. So he says entire earth is made up of continents and ocean basins. Continents are resting on the oceanic basins. And what are the continents? He said continents are large continuous visible masses of the land separated by the oceanic water or huge seas. Okay, so sea is large continuous masses of land. So he is saying continents and oceanic basins are two different types of lands, and continental land masses are resting over the oceanic land mass. Not just resting, it is sliding over, or actually it is walking over the oceanic basins. Understanding? So according to Wegener, he said earth is made up of 3 layers. Continents are made up of sial, silica and aluminium. Oceanic basins are made up of sima, sial and magnesium. That's why they are different. And then you have a core. So he said there are only 3 layers of the earth. continental basins, oceanic basins and core of the earth. Continental basins, continents are sliding over the oceanic basins. Okay. So simply what he said, continents are sliding over the oceanic basin. And because of that, one region is shifting its place from one climatic zone to another climatic zone. And that's why in different time period, it is facing different types of climate. So this theory is known as continental drift. Drift means actually the sliding over. So he says continents are drifting over the oceanic basins. That's why continental drift. Okay. So according to Wegener, at one point of time, all continents were together with each other. Okay. And there was a supercontinent. And all oceans were together. There was a super ocean. So supercontinent was known as Pangea. Pan means all. Gea means earth. Ocean, Panthalassa. Thalassa means water. Pan means all. So all water, all landmass. So they were all together. Then what happened? One event happened. Because of that, the supercontinent broke. When the supercontinent broke, the different parts of the supercontinent traveled in a different directions. And what we have today is today's arrangement of the continent according to Wegener. Okay. So according to Wegener, this Pangea was initially broken into two parts. The northern part is known as Laurasia and southern part is known as Gondwana land. And a small baby ocean formed in between. This ocean is called as Tethys Sea. Okay. So breaking of the Pangea. This event is called as breaking of the Pangea. Okay. So Wegener talks about there are various our country it was a part of Gondwana land. India was a part of partially part was the Gondwana land. Partially India was a part of Laurasia also. Okay. Some countries like Africa was completely part of Gondwana land. South America was completely part of Gondwana land. So different countries that we have today, different continents were part of either Laurasia or Gondwana land at that point of time. Okay. So according to Wegener, this Pangea broke and different parts travel in a different direction in a different time period. Okay. Some Pangea broke 225 million years ago according to Wegener. Then the next arrangement, Laurasia and Gondwana land completely separated 150 million years ago. Okay. Then further this Laurasia and Gondwana land broke and 100 million years ago different continents separated, and current arrangement is there which we can see right now before few million years ago. This is the overall Wegener's explanation of the theory. Okay. So this is all his thinking process. Okay. Now it needs evidences. So they ask him for the evidences. Give us evidences. What you are talking is very logical, but logic you can prove it in any way. See, the logic is very good, but if you have evidences, you can prove it in any way. You go to the court and you see the lawyers, both the side lawyers, they talk logically and both prove that one proves that the particular person is guilty and his lawyer proves that's not possible. He cannot even kill the mosquito. Okay. So logic is such a thing. So science has this drawback. Okay. The logic is a power of science as well as is a drawback of science. Because with evidence you can prove anything. Logically anything you can prove. Though it is not true, in the false thing you can prove as a true using the evidences. Okay. But logic is also one of the most beautiful things. So they said give us the evidences. So Wegener said okay, I'll give the evidences. So he gave evidences in the categories of 3 to 4 times. So he divided his evidences in 3 to 4 types of categories. He said I'll give you geological evidence, I'll give you climatological evidence, then I'll give you floral and faunal evidences. Okay. So geological evidences he gave was in the form of jigsaw fit theory. Jigsaw fit everyone has played when we were children. Okay. So he said that if you see, so he a kind of gathered boundaries of all the continents and he tried to fit all the boundaries together. So he said boundaries of many continents are fitting with each other almost perfectly like a jigsaw fit. Okay. So eastern coast of Atlantic and western coast of Atlantic, they are completely fitting each other. Okay. Then he show other continents as well. So they are completely almost fitting with each other. So this was his first evidence. He said this fitting with each other itself shows at one point of time they were together. Understanding? Okay. So this is called as a jigsaw fit theory. So he gave the evidences of some mountains. Okay. So Caledonian and Hercynian mountain system. Okay. These mountain systems are there on the eastern and western coast of Atlantic. He said they are almost similar. Similar in terms of age, similar in terms of rock structure. So this, he said, this is not just a simple coincidence. At one point of time, these mountains were joined. Then they broke away from each other. When continents broke, they broke away from each other. Okay. So Caledonian and Hercynian mountain system. Also he is saying vegetation. Look at the vegetation on eastern coast of the Atlantic and western coast of the Atlantic. They are almost same. The types of species, okay, the types of animals, they are almost same. They cannot cross this, animals cannot cross the huge ocean and swim and go another side. So this was the second evidence. Rocks of the same age. Another geological evidence, he said if you see the Atlantic coast, rocks of the same age are there on both the coasts. If both were not together, then these rocks would have formed in a different time period. But it shows that the rocks were formed in the same time period. This also logically proves that they were all together. East and western coast of Atlantic. Okay. So these were evidences called as a geological evidences. Then he said, I'll give you some paleoclimatic evidences. Paleo means what? Old. Paleo means old. Okay. Climatic means what? Climatic. Paleo word kahin pe bhi aa jayega, understand its meaning is old. Paleomagnetic evidences means old magnetic evidences. Paleoclimatic evidence means old climatic evidences. So paleoclimatic evidences he gave in the form of glaciation. So Wegener found out glacial deposits in various continents like South America, Africa, India, Antarctica, Australia, Madagascar. He said during the period of glaciation, you know, wherever glacial is formed, it erodes the ground below. Okay, it's called as glacial erosion. So after glacial is melted, that eroded part of the ground remains there in the form of glacial till, okay, or glacial deposits. So he said these glacial deposits or glacial till has the same characteristics. It is formed in the same time period. So this shows that one entire glacial was occupying all these continents together. So glacial till found on these 5 to 6 regions in the world, he says it shows that all these parts were together. All the parts of these continents were together at particular period of time. Now they got separated and they moved from one place to another place. Okay. So this is another evidence called as a paleoclimatic evidence in the form of glacial till or thick tillites. See, glacial till means what? See, what Wegener is saying, that all these continents were together and one glacial was occupying all these continents. So whenever glacial is there, because of the weight of the glacial, the rock beneath the glacial, it erodes. Okay. So when glacial is melted, whatever eroded material is there, it is not going to go anywhere. It is going to be deposited there. So whatever material which is being deposited, eroded material is being deposited there, it is called as a tillite or glacial till. So Wegener collected all the glacial till, he observed it, he analyzed it, and he said that all the till which was formed have same properties, they have formed in the same time period, same glaciation period. So he said it shows that entire period, all the parts of the continents were together and occupied by the same glacier which eroded them, the huge glacier. Okay, so this is called as a glacial till or paleoclimatic evidence. Okay, then he also gave the placer deposits evidence. It is also kind of geological evidence. Okay, placer means what? Placer means let us say a mine of a very valuable mineral, or let us say in a river you have a sand in which you find a gold. So that sand is called as a placer deposit. Okay, so anywhere you find the valuable mineral, the deposits of is called as a placer deposit. Okay, so this placer deposit evidence was given by the Wegener in the form of eastern coast of Brazil and western coast of Ghana. So he said, see gold, see wherever you have gold mines, you have seen the KGF movies, okay, it's all about gold mines. So wherever you have gold mine, actually the source of gold is very deeper in the earth. When the gold comes out, okay, it comes through the volcanic pipes. Okay, in geographical terms, it is called as a veins. Okay, veins. So Wegener told that the veins of this gold mine are located in the Brazil, but actual gold is located in the Ghana. You know, Ghana is very famous for the gold, diamonds. Okay, have you seen the movie Leonardo DiCaprio, Blood Diamond? Okay, there is a book on this. Okay, so Africa is very famous for diamonds. Africa is very famous for gold. So Wegener is saying that the veins are there in the Brazil, but actual gold mines, more number of gold mines are in the Ghana. How it is possible? Wherever there are veins, there should be mines. This shows that Ghana and Brazil were together at one point of time. Understanding? So eastern coast of Atlantic and western coast of Atlantic, okay, so he is saying they were part of the same continents. For Africa and South America were together at one point. Understood? Okay. So placer deposit is one of the important evidences given by the Wegener. Then he speaks about floral and faunal evidences. What is a floral and faunal evidence? Okay, floral means what? Yes, floral means botanical plants. Fauna means what? Animals. So he is saying, if you see the various species on all the continents, some species of the plants are not supposed to be there on a particular continent. How it is there? Okay, it was supposed to be in another continent. So let us say Glassopteris. Okay, so he said, or simply, okay, Glassopteris, let us say, is found in India, South Africa, Australia, Antarctica, Falkland Islands. So he said how this plant can travel in all the continents, which is separated by huge expanses of water. Not possible. Okay. So this is also one evidence as he shows that all the continents are together. Okay, let us say you might think that with the wind, spores went there or seeds went there. Okay, the worst of the worst possibility we consider that, okay, winds, somehow it managed. Let us consider lemur, monkey, a small lemur. You see Discovery Channel, okay, lemurs. So he said lemurs are found in Africa, India and Madagascar. Now this small monkey cannot jump that far. Neither he can fly with the winds. So how this lemur is going from Africa, Madagascar to India? So this entire thing is called as a Lemuria. Okay. So he says it shows that Africa, India and Madagascar, they were together at particular period of time. Understanding? Okay. Same he is talking about Mesosaurus, a brackish water animal. Okay, a reptile. So his Mesosaurus is traveling from Africa, America to various parts of other continents. So same thing like a lemurs itself. Okay. So he say its skeleton is found over Africa and South America. Now Africa and South America again separated by the Atlantic Ocean. Mesosaurus cannot, he is a brackish water animal, he cannot go in the salt water, he will die. Even he wants to swim, he will die. So that shows that they were together at point of time, one point of time. Now they got separated. So this is a floral and faunal evidence. Understood? Okay. So these are the various evidences given by the Wegener, and UPSC can ask you the question, okay, about particular evidence. They can ask about where are the gold veins and where are the gold mines. Okay. They talk about Mesosaurus. They can ask about lemurs, Glaciopteris. Okay. So these small questions can be asked by the UPSC. Now Wegener has proved everything logically. Okay. Continents were together. No questions. Very difficult to question his theory. But now somebody asked him, what are the forces responsible for the breaking of the continents? So whatever you call it as a continental drift theory, its drawbacks started coming only after Wegener started explaining the forces responsible. Because at that time, he did not have instruments to know what is there under the earth which makes it to move from one place to another. Okay. So forces responsible for drifting. Wegener said it's a gravitational pull of sun and moon. He's saying gravity of sun and moon is so strong, it is creating huge amount of tides. So it is also pulling the continents. This was the first thing he said. Second thing he said, buoyancy force. Buoyancy, you know? Okay, why ship floats in the water is because of buoyancy. Water is also pushing the ship opposite direction. So he said this buoyancy force is the second force responsible for the continents being pushed. So first force is gravitational pull of sun and moon. Second is a buoyancy force. So it was difficult to digest because these forces are not that so strong, they will pull the entire continent. Okay. So then they asked, what about mountains? What about island arcs? How they are formed? How volcanoes are formed? So Wegener said, see, initially what he said, continents are effortlessly drifting over the ocean floor. Now, while explaining the mountains, he said, when continents are drifting over the ocean basins, because of the friction, the edges of the continents got twisted in the form of mountain. So initially you are saying it's effortlessly they are drifting. Now you are saying friction, it needs to be very strong friction, then only such a huge mountain can be formed like Himalaya. And there is no sound. You know, little bit of friction you do, just you do like this, there is a sound. Now a huge mountain is getting formed with the friction. How big sound should be there? There is no sound formation of the mountain. Okay. So here he could not explain the formation of mountain properly. Third, they asked how island arcs were formed. Island कैसे form हो गए? So he said, when continents were drifting from one place to another place, small parts of the continents, they remained behind. Big continents traveled far and the small parts remained behind. He said, like in fair, children are walking with their parents and watching something, they remain behind the parents and parents walk ahead. Like that this happened. So because of that, inside the ocean you have a lot of island arcs. So this was also difficult to digest. He called differential rate of drifting. Okay, differential rate of drifting between big continents and small island, the parts of them. So parts remained behind and continents moved ahead. Okay, so so these are the important things. Okay, these are the important limitations. Okay, which made Wegener theory little bit doubtful. He could not explain origin of all these things. Okay, but if you see the theory of Wegener, in many senses it was a very foundation stone for the discipline of geography. So later thinkers they came, later geographers came, they worked on the continental drift theory and they improved the continental drift theory. And today whatever the progress of geography we have, Wegener has a very huge contribution for that. So later geographers they came, they said, okay, let us deal with those limitations and come out with the new theory. So new theory came out of their efforts, and this theory is known as plate tectonic theory.
So can you explain the second point?
What is the point?
We did not describe the situation pre-carbon test report.
Yeah, so 225 million years ago he said the first Pangea was together. So he said Pangea was together, okay, 225 million years ago. So he did not explain what happened before that. Pangea was together 225 million, but Earth's age is 4.5 billion years ago. So what happened before that? He could not explain. That is also a drawback, because he did not have those instruments, he did not have those capabilities at that time. Okay. So to improve the theory of Wegener, many people came ahead. They worked with the many postulates that Wegener put forward, and a constellation of few theories has been formed. This new theory, made up of many small theories, is known as plate tectonic theory. Okay, so here plate tectonic theory, if you see, first let us understand, to remove the drawbacks of the Wegener's theory, first thing they did is they studied the interior of the earth properly. They established the layers of the earth properly. Just by establishing the layer, they could remove many drawbacks. So they said, no, the earth is not just like Sial, Simon core. It has an oceanic crust, it has a continental crust, then it has a mantle, core, outer core, inner core, asthenosphere, so many things are there. Okay. So first thing they said that it is not continents that are moving. Continents and ocean basin both are stable. What is moving? Is the whole plate is moving. Along with ocean water it is moving, not just it is moving, along with ocean water it is moving. Okay. So this theory is called as a plate tectonic. So they talk about plate. So this, what you can see, is a plate. Okay. So plate, what we have seen, is nothing but a part of crust and upper mantle. So this part of crust and upper mantle is floating on the asthenosphere. So this part of crust and upper mantle, what do we call it as? Very good, lithosphere. Okay. So this lithosphere is divided into various parts, various slabs. So the plate is nothing but a slab of lithosphere floating over the asthenosphere. Understood? Okay. So they said it is not a continent that is moving, but what is moving? Plate. So J.T. Wilson, he gave the concept of plate. Okay. So Wilson spoke about plate. So then Wilson spoke about plate. Then Arthur Holmes came. Wegener could not explain the force behind the continental drift. So Arthur Holmes spoke about convectional cell. Okay, or he spoke about the magma cells. So what are these magma cells? What are the convectional cells? Okay. So as you know, Wegener could not explain the force responsible behind the drifting. So Arthur Holmes and team, they said it is not the outside tidal force or gravitational pull of sun and moon. The force is coming from within the earth itself. Okay. So this force is coming in the form of rising magma. Magma, very hot magma is rising towards the crust. It is going, meeting the crust, getting cooled. Again, it is subsiding down. Again, it is getting hot. Again, it is rising. Again, it is subsiding down. So the process of rising, then spreading along the plate beneath and getting cooled and subsiding down itself is creating the kind of force, because of that plates are either moving away from each other or towards each other. So this convectional cell is one of the important forces that he said is responsible for the movement of the plates. So these are the convectional cells. So they are rising, and since they don't have any other way to travel further, either they can come out in the form of lava, or second, they can subside beneath the plates. When they subside beneath the plates, they will travel in the different direction, which will break the entire crust or lithosphere into plates. And these plates will travel in the opposite direction or towards each other. Understanding? Okay. So this is all the concept of convectional cell. So convectional cell theory, if you see, convectional cell has a limbs. Okay. So here you can see the magma is upwelling or moving upward. When it moves upward, okay, it will strike the lithosphere. Okay. If the convectional, this upwelling is very strong, it will break the entire lithosphere. Okay, and it will create two plates. Either it will break the entire lithosphere, create two plates, or it will just create a small hole. And from the small hole, a small volcano will come out. Two things can happen. If a small volcano comes out from there, we call it as a hotspot. Have you heard this word called hotspot volcano? Okay. So if the convectional cell is not that strong, which can break the entire plate, it will just create a small hole in the lithosphere and a hotspot volcano will be formed. Or if it is very strong, after a few million years, it will break the entire plate. Now the entire plate is broken. So a limb of this convectional cell, it will either go in the opposite direction. So when it goes in the opposite direction, it is called as a divergent limb. Okay. Whenever there is a divergent limb, plates move away from each other. Whenever there is a divergent limb below lithosphere, plates will move away from each other. Now you have multiple divergent limbs, but somewhere these limbs will come together. They will come towards each other. Now you can see this is a divergent limb which is coming from this direction. Another side, another divergent limb is there. So two divergent limbs are coming and meeting here. So two plates will come and meet each other. So this limb is called as a convergent limb. So under lithosphere, two limbs are converging with each other. So plates will also collide with each other. Here, two limbs are going away from each other. So plates will also go away from each other. Okay. So here you have a divergent limb. See, this is a divergent limb. Understanding? Okay. So this plate concept was given by J.T. Wilson and convectional cell theory was given by Arthur Holmes. So these two theories, convectional cell theory, it solved the problem of force responsible for drifting. Okay. And the overall interior of the earth which was studied, it solved the problem of what is moving, whether continent is moving or oceanic basin is moving. Understand? So J.T. Wilson, when he spoke about the concept plate, he spoke about various types of plates. So can you tell me how many types of plates are there? Yes.
Major and minor.
Okay, that's the size of the plate. Okay, okay. So in terms, we have three types of plates. These are boundaries. In terms of plates, we have continental plate, we have oceanic plate, or we have combination of both continental and oceanic. Simple. Okay. So these are three types of plates. And definitely.
So that convection cell theory was another and plate tectonic is another.
No, all this together we call it as a plate tectonic.
So the convection cell was given by someone else and this plate is given by someone else.
Yes. So there is convectional theory was given by Arthur Holmes and the concept of plate was given by J.T. Wilson. Okay. So all these people, they spoke about plates, how they are moving, okay, entire mechanism of the movement of the plates. So this entire thing is called as a plate tectonic.
Cell of the reason which they gave for movement of plates is different and this plate tectonic reason is different.
No. In the end, your doubt will get solved. Okay. Okay. At the end, everything will be solved. So here he is talking about three types of plates. Okay. Oceanic plate, continental plate, or combination of oceanic continental plate. Okay. So oceanic plate is always heavier than the continental plate. So why it is heavier? Because oceanic basin is a denser. Continental basin is not denser. So oceanic plate is always heavier plate. Continental plate is a lighter plate. Understanding? Okay. So what happens when these plates are moving? When they move towards each other, they collide each other, then the collision of two plates happen. When the collision of two plates happen, the place where the collision happens, it's called as a boundary zone or plate boundaries. So plate boundaries are of different types. But when oceanic plate and continental plate, when they collide with each other, definitely one plate has to be subducted. So which will subduct? Heavier will subduct because it is heavy. So oceanic plate will always subduct, continental plate will always remain on the top. When two oceanic plates are moving, who will subduct? Heavier out of them will subduct. And when two continental plates are meeting each other, no. Here no subduction happens. Both of them rise together. Okay. And they create a mountain. So in case of continental plate meeting, no subduction happens. Both of them collide and rise. Okay. So he spoke about various types of plate. Yes, there are major plates and minor plates. Okay. Major plates, the area is more than 20 million kilometer square. Remember this. Minor plate, area is less than 20 million kilometer square. So there are many minor plates. Okay. So many minor plates are there. 6 to 7 major plates are there. Eurasian plate, North American plate, African, Pacific. Okay. These are major plates. Then you have minor plates like you have Caribbean plate, Arabian plate, Nazca plate, Cocos plate. Okay. These are small plates. Okay. So major plates and minor plates. Now these plates are meeting each other. They are colliding with each other. So it is called as a plate boundaries. Plate boundaries are very important. Why they are important? Because whatever most of the events happen, they happen on the plate boundaries. Generally, interior of the plates, geographic events don't happen there. Where do the events happen? On the plate margins or plate boundaries. That is the region where all the action happens. Okay. So volcanism, earthquake, formation of the mountain, Okay, folding, everything mostly happens on the margins of the plate. That's why plate margins are very important. So there are different plate margins. Okay, so first plate margin is a constructive plate margin. Which plate margin? Constructive plate margin. Because here new plate is getting constructed. So it is called as a constructive plate margin. Okay. Now here if you see, because of the convectional cell which has a divergent limb below the lithosphere, two plates are moving away from each other. Okay. So two plates are moving away from each other. It is called as a divergent plate margin or accreting plate margin. These are a few more names. So what happens when two plates are moving away from each other? The magma is coming and filling the gap. It is getting solidified. When it is getting solidified, a new oceanic crust is being formed. Because the new oceanic crust is getting constructed, you are calling it as a constructive plate margin. Understanding? And where the constructive plate margin is there, a small chain of mountain is formed over here, just along the constructive plate margin. They are called as a mid-oceanic ridge. क्या बोलते हैं उसे? Mid-oceanic ridge. So these are the longest chains of the mountain in the world. So उनका height होता है 2000 meters, up to 2000 meters maximum. Okay, they are formed on both the sides of the plate margin. Understood? So both the sides of plate margin, these mid-oceanic ridges are formed. Understanding? Okay. So constructive plate margins, they are very important. Okay. Now, under the ocean, if constructive plate margins are formed, then you have mountain chains on both the sides, called as a mid-oceanic ridge. But same constructive plate margin is formed under the continent. Then what happens is a little different. So if constructive plate margin is there, first the continent starts splitting. See how lithosphere starts breaking. Understand this. First continent starts splitting. Okay, a small valley forms which is called as the Rift Valley. What it is called as? Because further this gap widens and a small baby ocean forms in the Rift Valley. It is called as a nascent sea. Geographical language, it is called as nascent sea. Okay, so this baby ocean is called as nascent sea. Then this baby starts growing. Slowly it becomes big, a full-fledged ocean. This is how oceans are formed. New oceans are formed. Okay, new oceans are formed because of the constructive plate margins are there under the continents. You know the example of Rift Valley right now? Great African Rift Valley. Okay, in the Africa you can see here, okay, this place called as a Great African Rift Valley. There are great lakes in the Africa. They are around this Great African Rift Valley. Okay.
The Rift Valley.
Yeah, it's okay. Karan sir का birthday.
आपने तो शुरू में बताया ना होगा कि आपने बिगिनिंग का जो ओशन में होगा अपने बाद में तो लोगों में कह रहा हूँ कि कब ओशन में हो रहा है कब लैंड पे हो रहा है.
See, when it happens we don't know.
आपने बोला कि लैंड हो रहा है तो रिफ्ट वैली हो रहा है और ओशन में हो रहा है तो
Mid-oceanic ridge is getting on. So what is the question?
मैं कह रहा था कि आप एक
No, टेबल बनाने की कोई जरूरत नहीं है. सिंपल देखो, if the divergent plate margin is formed under the ocean, you have mid-oceanic ridge. The ocean is expanding. A new oceanic crust is getting formed. The same divergent plate margin is there under the continent. Then what happens? First rift valley forms. Then that rift valley gets converted into nascent sea. Then that nascent sea becomes ocean. It just size is increasing because plates are. See, both the sides of the continent, what you have? Ocean. So entire continent is splitting here. So the water will enter from both the sides. See, now here, Africa is splitting here. See, Africa is splitting here. This is Great African Rift Valley here. Okay. Now, as it starts splitting, water from the Indian Ocean, water from the Red Sea, they start coming and filling the place. Understanding? So, let us say after 10 crore years ago, after 10 crore years, this part of the Africa will be completely separated from Africa. Look at here, look at here. Like this, the entire part of the Africa from Great Rift Valley will be separated, and this nascent sea will be born like this. Now again it will go on separating further, it will go on traveling further, and this sea will widen. After 1 million years ago, not ago, further. Okay. Another example of nascent sea is a Red Sea. Red Sea is also a nascent sea. Understanding this? So it is also widening. Okay. After few years, these both seas will merge. Let us say 50, 20, 30, 40 crores years later, both Red Sea and the Rift Valley which has been formed over here, they will merge with each other. Okay. So the Red Sea here again is a nascent sea and it's expanding. Understanding, everyone? Okay. No need to have a table, nothing, very simple. You'll remember it? Okay. So this is the constructive plate margin. Okay. Now, next is a destructive plate margin. So here, plates get destroyed. That's why you are calling it as a destructive plate margin. Constructive plate margin, plates were getting formed. Here, plates are getting destroyed. So, destructive plate margin, it is also called as a consuming plate margin or convergent plate margin. Okay. So, these plate margins, destructive plate margins are of three types. What are those three types? Oceanic plate margin, Oceanic continental, continental. Okay. So oceanic plate margins, if you see, this is an oceanic plate margin. Two oceanic plates are meeting with each other and heavier is getting subsided. Heavier is getting subducted. It is melting. When it melts, a gases comes, they break the lithosphere of another plate. And from them, lava comes out. And it creates a small mountain inside the ocean. Like this, the chain of mountain forms on the margin of another plate. So in this way, island arc is formed. Understanding how island arcs are formed? Because one oceanic plate is undergoing another oceanic plate. A gaseous and hot lava of subducting plate breaks the crust of another plate. From that, magma comes out in the form of lava and a chain of mountain forms on the entire plate margin. This is called as island arc, because the whole plate you'll have mountains like this. So it will look like an island arc. Understanding this? So Wegener could not explain the reason behind formation of island arc. So this reason was explained nicely by the destructive plate margin theory and findings. So there are thousands of island arcs in Southeast Asia. Whatever you see, Indonesia, Singapore, Borneo, Thailand, they are made up of these thousands of island arcs. So if you see the Southeast Asia, there are many oceanic plates. They are subducting under each other. There is a Sunda plate, there is a Pacific plate, then there is a Philippines plate. So they are all colliding with each other, subducting under each other, and inside Southeast Asian Ocean, in the Pacific Ocean, so many island arcs have been formed. Okay, so you have Sumatra, Java, okay, Borneo, so many islands are there. These only famous we know, otherwise there are millions of islands are there. Understanding? Okay. So this is how destructive plate margin, though it destroys the plate, but it also creates the volcanic mountain. So when destructive plate margin happens under the ocean, thousands of island arcs are formed. Now, second type of destructive plate margin, Oceanic Continental. When Oceanic plate meets with the continental plate, Oceanic plate subducts under the continental plate. And again, the part of the plate which goes down, it starts melting. Gases and magma breaks the crust of another plate, and a chain of mountain or a line of a mountain is formed on the margin of another plate. Okay, so Andes and Rockies is an example of this in the America. So why on the margins of the continents you have a mountain or chain of the volcanic mountains? It's not because Wegener was saying it get twisted because of friction. It is because of meeting of two plates, oceanic and continental. So which plates are meeting? So here if you see, Nazca plate is undergoing the South American plate. Okay, so Nazca is a oceanic plate. It is undergoing the South American continental plate. So it is contributing in the formation of Andes and Rockies mountains. Understanding this? Okay, but in Andes and Rockies mountain there are also fold mountains except volcanic mountains. Understanding? Okay, so this is a second type of destructive plate margin. Now third type of destructive plate margin. What is the third type? Continent-continent meeting of the plates. So when continent-continent meeting happens, as I told you, no plate is going to get subducted. Both the plates are going to rise in the form of mountain, which is called as a fold mountain. So fold mountain is formed when two continental plates are meeting with each other. So fold mountains are there everywhere. Okay. So process of formation of fold mountain is we will also see that how Himalayas were formed in the Indian geography. We will see that. Okay. In detail we see that. But the main reason behind the formation of fold mountain is meeting of two continental plates. Okay. Now third type of boundary is called as conservative plate margin. So constructive plate margin is finished, destructive plate margin is finished. Now conservative plate margin. In conservative plate margin, no plate is created, no plate is destroyed, because plates just slide past each other. So when plates just slide past each other, there are a lot of tremors. It's like that. See, sometimes you are walking in the crowd. Okay. Some people collide with each other in the crowd while walking, nose is broken. Okay. Sometimes you just slide past each other, you shake. So same thing happens with the plate. Plates shake. No volcano, nothing. But continuous earthquake. One after one you'll have earthquake. One after one you'll have earthquake. Okay. So these are conservative plate margins gives lot of earthquakes. So people living around the conservative plate margins, so life is very difficult because continuously earthquakes are happening. Okay. The example of the San Andreas fault in USA. On this there is one movie. Okay, one Hollywood movie is there, San Andreas. Okay. So here the two plates are moving away from each other, and because of that, okay, near California, okay, so San Andreas fault is an example of conservative plate margin. Just the plates are sliding past, and because of that, so many earthquakes. Okay, very difficult to sleep at such place. Okay, because regularly some tremors are happening here. Okay. So understand that this all thing is called as a plate tectonic theory. Not one part is called as plate tectonic theory, because everything is putting some focus on some aspect of the plate. Somebody is talking about interior of the earth, somebody is talking about the plate, somebody is talking about plate boundaries, somebody is talking about convectional shell. So because of that, everything together comes under the plate tectonic theory. So plate tectonic means formation, destruction and movement of the plate. The meaning of the plate tectonic, what is the meaning? The formation, destruction, movement of the plate is called as a plate tectonic. And all these sub-parts, sub-theories, they explain this formation, destruction and movement. So that is why it is called as plate tectonic theory. So plate tectonic theory answered how many questions? Almost all the questions. Whatever Wegener was talking about, all the questions were answered by the plate tectonic. First, forces behind the movement of the plate, how mountains are formed, what is the interior structure of the earth. Okay. So reason for the volcanoes, types of mountains. Okay. This theory is talking about various types of mountains. Understood everyone? Okay. Any doubt? Now, as you know, plate tectonic theory itself is a very big feat, okay, to deal with the interior structure of the earth. To prove the plate tectonic theory, it takes another theory. Plates are moving. How you are going to prove that? Yes, you are sitting on the plate, but it is moving because you don't feel it is moving. Even earth is moving, you don't feel that. Plate is also moving. Everything is in the movement. But how you will prove that? Evidences. So, the proving of the plate tectonic theory, all the postulates, the plates are moving and plates are there. Okay, plates are there, but how you will prove that plates are there? Are you going to take me to the bottom of the ocean? मेरा मुंडी पकड़ के ऐसे लेके जाओगे, देखो इधर प्लेट है करके? नहीं. You have to prove it some other. Okay. So, a next theory called as the sea floor theory, sea floor spread theory. The sea floor spread theory worked on giving a concrete evidences that plate exists, and plate margins are the places from where plates are either moving away or towards each other. Okay. So the sea floor spread theory was first given by Harry Hess. Okay. So Harry Hess talks about how the sea floor spreads and he gives the evidences. Now, Harry Hess tells that now the postulate of this theory is sea floor is continuously spreading at the mid-oceanic ridge. Okay. So sea floor is continuously spreading at the mid-oceanic ridge, and from there magma is coming out. And the magma is pushing the plates on both the sides. Because of that, plates are moving. This is a simple thing has been established by the sea floor spread theory. Now, how you will prove that plates are moving at mid-oceanic ridge? How you are going to prove that? Because they are moving like 1 centimeter per year. That also at the bottom of the ocean. So how you are going to prove that? So again they used one more phenomena called as a geomagnetism and paleomagnetism. We have studied geomagnetism. What we have studied in the geomagnetism? That entire earth is a magnet. Now understand, when iron comes in the contact with the magnet, what happens? It gets attracted and iron also becomes magnet. Any magnetic thing which comes in the contact with the magnet becomes like starts acting like a magnet. At least for a minute it will act like a magnet. Okay. So in the rocks which are coming, the lava which is coming on the top and making the mid-oceanic ridge, it is getting solidified. And in that magma, you have magnetic elements. You have iron, you have nickel, you have cobalt, you have so many magnetic elements. So these magnetic elements get magnetized according to current magnetic orientation. I told you magnet keep on flip-flopping, magnetic poles keep flip-flopping, north goes to south, south goes to north. So whatever type of magnetism is happening in the current period, the rocks which are being formed at the mid-oceanic ridge, they record those magnetic imprints. The elements in those lava, when they get solidified, they solidified by recording the magnetic imprints in the rock. They organize themselves, magnetic elements organize themselves according to current orientation of magnetism. And these properties of the rocks are studied in the laboratory. And based on that, you can conclude that how many years back these rocks were formed. Okay. So, by studying the paleomagnetic evidences at mid-oceanic ridge, the Harry has proved that rocks which are closer to the mid-oceanic ridge, they are recently formed rocks. And rocks which are away from the mid-oceanic ridge, they are old, previously formed rock. Also, rock bands or the magnetized bands of the rocks, they are at equal distance from the mid-oceanic ridge. And the size of the band is, so here you have mid-oceanic ridge. Okay. So what happens, whatever rocks are being formed, they are being formed according to current magnet, the bands of the rocks are formed according to current magnetic field. And they are equidistant from the mid-oceanic ridge. And based upon the length of these bands, you can decide the rate of the movement of the plate. How many years back it moved. Depending upon the width of the band, you can say for how many years the particular magnetic orientation of the Earth's magnetic poles remained. How many thousands years magnetic poles were there at particular place. And after how many thousand years the position of the pole changed. Also based on that you can determine the speed of movement of the plate, speed of the ocean floor spread. Okay. So using the paleomagnetism, geomagnetism, Harry Hayes and the team, they proved that sea floor is spreading at the mid-oceanic ridge. Plates exist and they don't exist, they move from one place to another place. Understood? Okay. So see, these rock bands, the magnetic field in the rock which is being imprinted, It is recorded in the form of positive and negative magnetic anomalies. What is positive and negative magnetic anomaly? See, when south pole of the magnet is closer to the north pole, geographic north pole, it is called as negative magnetic anomaly. When north pole of the magnet is closer to the geographic north pole or coincides with the geographic north pole, that period is called as a period of positive magnetic anomaly. When flip-flop happens and south pole comes to the north side, it is called as a negative magnetic anomaly. See, you have a compass in your hand. Compass shows north pole, north direction. Actually, compass works on magnetism. Okay? In reality, that is the south pole. Because opposite poles attract each other. Understanding? So, whatever compass is showing north direction, because south pole is attracting to the north pole. You know, equal pole repels in the magnet. Okay? So, in compass, though the north direction is shown, but actually that is a south magnetic pole. But geographically it is showing correct. So, we are using that to identify the geographic pole. Understanding? Okay? So, this is sea-floor spread theory. So, sea-floor spread is mostly very important for mains, but still we should know what it is. Okay, very important. So, all these findings, they came out of the sea-floor spread theory and continental drift theory. So, Atlantic and mid-oceanic, at Atlantic Ocean, mid-oceanic ridge is spreading at 1.5 centimeter per year. In the Pacific Ocean, okay, mid-oceanic ridge is there in each and every major ocean. Each and every ocean, almost each and every ocean, you have mid-oceanic ridge. Understanding? Okay, Indian Ocean also you have mid-oceanic ridge. Everywhere you have mid-oceanic ridge. Because without mid-oceanic ridge, ocean cannot form. There is no other way ocean cannot form. Okay? So, every ocean has a mid-oceanic ridge. So, there are so many findings which came out of plate tectonic theory. Okay? So, Mediterranean Sea is a residue of Tethys Sea. See, Tethys Sea has many residues. Okay? What you call as a Mansarovar. Mansarovar, Lake Baikal, they are also residue of Tethys Sea. Mansarovar is a pilgrim site, is always in the news. Kailash Mansarovar because of India-China clash. Mansarovar is supposed to be a residue of Tethys Sea. Mansarovar is like an open secret of aliens. You know, people see, and armies and all, they have recorded a lot of alien activities, spaceships and so many things were there. Okay, so this is the oldest place. They say that there are alien bases under the Mansarovar. There are theories like that. Nobody is allowed to go there. Okay, pilgrims are also just go, they take bath and they come out. In Kailash, nobody is allowed to touch there. People cannot even go, and they say it is not possible to climb the Kailash. So many people have tried this, but they just came back because they say something happens when we start going near the Kailash, we come out. Okay, so nobody has climbed the Kailash till date. Nobody has climbed. It is even smaller than it's just 6,000 meters or something like that. Lower than the Mount Everest. But nobody has able to do it. In Mansarovar, nobody has went the bottom of the Mansarovar. You know, you have Pangea Lake, so many nearby lakes in the Himalayas. So people, these armies are building boats and so many structures under at the bottom of the lake. But Mansarovar, nobody touches. China does not touch it. Because they said there are alien bases downside and they don't want to disturb them. Okay, because everything is going fine. Let us not go into their way. They are not coming in your way. You don't go in their way. It's like that. And they say it's an open secret. Okay, so that is considered as a residue of the Tethys Sea, the oldest sea. Okay, so we have seen that Red Sea has started to open. Okay, what will happen to the Great African Rift Valley also we have seen. So as one of the drawback of the Wegener that he could not explain what happened before Carboniferous period. All these things. So before Wegener explained that first plate tectonic started 300 to 200 million years ago. Continental drift started. But plate tectonic established there was one more cycle of Pangea and Panthalassa breaking happened between 600 to 500 million years before. So they say this is a continuous process. Continents are coming together, breaking away, coming together, breaking away. It's a cycle. Everything is a cyclical in this world. Everything in geography, everything is cyclical. Starting from day, night to breaking of Panthalassa, Pangea, everything is cyclical. Okay. So there are various conclusions. Okay. All these things. Okay. Just go through them. Okay. Any doubt? Any doubt? Online students, any doubt? Yes.
Flash destroyed under the oceanic trenches.
What is the point?
Flash destroyed under the
What does it prove?
second point.
Plate tectonic theory. Plates are consumed and destroyed at oceanic trenches. Plates are consumed and destroyed. See, plates are formed at mid-oceanic ridge. New plates are formed at mid-oceanic ridge. So if plates keep on new part of the plate is going to get formed continuously, the size of the earth will increase. Logically, if you say at mid-oceanic ridge, if oceanic plate is, the size is increasing, it is continuously spreading, slowly earth will become bigger and bigger and bigger, planet will swell. But it does not happen. Overall size of the planet remains same. Why? Because on opposite side, where destructive plate margin is there, the another part of the plate is getting destroyed on the another side. And wherever it is getting destroyed, it is called as the destructive plate margin. Understanding? So somewhere construction is going on, definitely somewhere destruction has to go on. This is a law of nature. Okay, everything simultaneously, two opposite things are always going on in the universe. Okay, a day, if you have a day in the half part of the earth, simultaneously night is going on in another part of the earth. Okay, so two opposite things are always going together. Same place where they get destroyed. Plates destroyed, destructive plate margin, that place is also called as oceanic trench. We'll see that also, it will come. Okay. So this is all geomorphological theories of continental drift, plate tectonic and sea floor spread. Okay. Let us see if they ask you this in your exam. So the forces, whatever we spoke or whatever this plate tectonic theory talks about, the forces are very important. These forces, now geographers have found, these forces give rise to various processes. They set up different processes. You know, any process to happen, you need force. So these forces, they set up small processes on the surface and interior of the earth. So they are called as geomorphic forces or geomorphic processes. So there are different processes these forces start. Which are these processes? Mountain building, movement of the plate, okay, breaking of the plate, folding of the plate, warping of the plate. Okay. So these forces, if you see, we can classify these forces into two categories. What are those categories? Endogenetic forces and exogenic forces. Endogenetic forces means what? Coming from within the earth. Exogenic means what? Outside the earth. So there are agents which produce force from within and there are agents which produce force from outside. So outside agents, what are the outside agents? Yes? Winds, sunlight, water, glacier. So they are outside agents. They are applying their force on the structure of the earth, and endogenetic forces coming from within. So they are same. Convective force, convective cell. Okay. So they are called as endogenetic forces. So energy is coming from within. So from where this energy has come? From where this energy has come within? So as we have seen, Earth was very hot. Only outer part has become cold, but inner part is still very hot. So this is called as a primordial heat. Is still trapped inside the earth. Okay. I don't know how much many of you have observed when you are eating food. You are eating rice, specifically in the cold season now. Rice is very hot. The outer part will become cold, but inside still the rice is very hot. The same thing is happening. Outside of the earth is very cold. It has been solidified, but interior heat is still trapped. At the birth of the earth, whatever heat was there, it is still trapped. Okay. So that heat is creating the endogenetic force. So inside you have radioactive elements. They are continuously decaying. Okay. They are also creating forces. Plus, there are a lot of tidal, tides are happening. Water is rising very high. It is coming and again on the oceanic floor. Okay. So it is coming and it is being dropped with a very high force. That is also creating a heat in the system of the earth. Understanding? Okay. So these are the various reasons why there is a heat inside the earth. That's why the endogenetic forces are being generated. Okay. So these endogenetic forces, they induces two phenomena, diastrophism and volcanism. Okay. Diastrophism means what? So plate tectonic is also a process of diastrophism, induced by diastrophism. Orogenetic or orogenesis means mountain formation. Epirogenesis means breaking of the plate, uplifting of the plate, faulting of the plate is epirogenesis. And plate tectonic. These three forces, these three processes are introduced by diastrophism. And second thing is volcanism. Okay. So these are very basic things and very important to understand. They are also part of your NCERT. Okay. So these are the different processes, and in exam they can ask the question on this. Okay. Specifically, this is the language is little tough. Diastrophism, epirogenesis, orogenesis. So just understand the meaning of these terminologies. Oro means what? Mountain. Genesis means what? Formation. Oppo. Okay. Epirogenesis means formation of plate, destruction of plate, creation of plate. Okay. Warping, continent building is all epirogenesis. And plate tectonic, movement of the crustal plate is all part of diastrophism. So in prelim they can simply ask which of the following is induced by the diastrophism. So first of all, we should know what is the meaning of the word diastrophism. Okay, then only we would be able to answer it. Understanding? Okay. So diastrophism. Then you have volcanism. See, volcanoes are always in the news. Keep on coming in the news. Very important. Mark them in your. I hope you guys have made this 100-page notebook. I told you, make it very important. See, this year you have 4 to 5 questions. Just if you know the place, why it was in the news, you will get the marks. It is as simple as that. No need to apply your brain at all. The simple exercise of this 100-page notebook will definitely help you. Okay. Mention all the volcanoes, whatever there in the news, whatever places are there in the news, small, just mention it. Okay. So volcano, what is a volcano and what is a volcanism? See, ism, wherever in geography ism comes, that means a process. Okay. So volcanism means a process where magma comes out from the interior of the earth to the surface. When magma comes out on the surface, it is called as a lava. Lava gets solidified, it forms rock, igneous rock. Yesterday somebody has some doubt about rock. Marble is a metamorphic rock, but granite is a igneous rock. Okay? Granite is a igneous rock. Marble is metamorphic. Okay? So M for metamorphic, yaad rakho. Marble metamorphic. Okay? Limestone is a sedimentary. Yes, marble will form metamorphism. Okay. So what is volcano? Volcano is a structure which is being formed when the magma from the interior of the earth comes on the surface. And around that magma, the structure is being formed which is called as a volcano. And the process of magma coming out on the surface being lava is called as volcanism. So volcano as a structure is at different parts. Okay. So you might have seen volcanoes like this. These are dead volcanoes, inactive volcanoes. Okay. So this is volcano. This is called as a volcanic cone. At the center there is a volcanic pipe which is connected to the source of magma called as a magma chamber. So through magma chamber, through pipe, volcano comes up. It gets accumulated around and it gets solidified and volcanic mountain is being formed. After this volcanic mountain is being formed, volcano becomes dead, inactive. Okay. Then what happens? This volcanic mountain slowly, the top starts collapsing. It becomes little big. See, it becomes bigger. Okay. Again, it becomes bigger, larger and larger. So it is called as a caldera. So mouth of the volcano, it becomes very big. It is called as a caldera. Understanding? Okay. So these are the different places where active volcano. The source of volcano is a asthenosphere. We have seen. Okay. These are the different parts of the volcano that I told you. There is a magma chamber, conduits or pipes. There is a vent from where it comes out, and the top of the volcano is called as a crater. The crater collapses, becomes caldera. Okay. So these are the different parts of the volcano. Okay. So volcanism happens at two plate margins. Okay. This is the destructive plate margin. Okay. Here what is happening? Simply mountain chain is being formed on the continent. Here inside the ocean, island arc is being formed. Also at mid-oceanic region, you have volcanoes. Okay. Mid-oceanic region, you have volcanoes being formed. So formation of volcano can happen due to these two types of plate. Third type of plate, volcanism does not happen. Okay. So lava is of different types. Depending upon what depth lava is coming, it can have a basaltic lava, andesitic lava, rhyolitic lava. Okay. So different types of lavas are there. Okay. So see the backside if it is there. $37. Okay. So it will be there definitely. Okay. So there are different types of lavas. Just go through them once. Okay. And I have given you one chart which shows about increasing quality of silica. Like basaltic lava, if you see, highly fluid and mobile, spread across easily, quiet eruption. Okay, so silica content is less in basaltic lava. As you go to the rhyolitic lava, silica content becomes very high. See, as silica content increases, the lava becomes more sticky. When lava becomes more sticky, the successive eruption becomes very violent. Like basaltic lava, you can sit on the edge of the volcano and simply watch how volcano is flowing. It is that beautiful. It will not harm you. You go to Hawaii Island, one of the major tourist destinations, there people will just go there on like their lava is falling in the ocean. People just watch how lava is falling in the ocean slowly, like that. But rhyolitic and Pelian type of volcanoes, when they explode, they kill thousands of people within few minutes, like that. So, how the eruption will be violent or non-violent will be depending upon the silica content. As silica increases, the mobility of the lava decreases and violent emission also is high. Understanding? Okay. So, I have given you this chart. It shows that silica contents increases, then lava becomes more violent and less mobile. Okay. So, there are various types of volcanoes. Okay, no need to go into detail. Subtypes are there, you know, they have been asked in previous exams. Okay, so let us see. First is a Hawaiian type of volcano. So Hawaiian type means Hawaii Islands are there in the Pacific Ocean near USA. So these Hawaiian type of volcanoes are they are basaltic eruptions. They are not very violent eruptions, and lava is not very violent. Okay. Then next is a Stromboli, Italy. Okay, in Mediterranean Sea, Strombolian volcano. So a little here, this one, this diagram you can see. Okay, so Strombolian type of eruption, if you see, it is a little more violent than the basaltic eruption or Hawaiian eruption. Okay, so you have pumice and scoria, these are the volcanic rocks. So eruption is violent, then these types of rocks also come out. Pumice and scoria. So again, next is a Vesuvius, again in the Mediterranean Sea. It is little more violent than the Strombolian. Mount Vesuvius is an example of that in the Italy. Okay, so this is a Vesuvius, Mount Vesuvius in the Italy. Okay, I am giving you this location because these are the living volcanoes, they keep on exploding. Okay, now Mediterranean volcanoes I have mentioned, you have to find out some Southeast Asian volcanoes. जापान में हमेशा होता रहता है, तो 2-4 Japanese volcano थोड़ा देख लेना. Okay, they keep on exploding this year, that year, something. Yes. So we'll use that. Okay. So next is a Vulcanian type of eruption. What is a Vulcanian type of eruption? It is lava is more sticky, more solid, less mobile. Eruption is more violent. So this is Vulcanian type of eruption. Okay. And example is Lipari Island. This is a Lipari. Again in the Mediterranean Sea, close to Sicily. Okay, Lipari you have over here. Next is the last one is the Pelian volcano. See, this is the father of all volcanoes. Very violent. Last time in the near Caribbean, when it emerged, how many people it killed? In one night, 28,000 in one night. So it is like that type of volcano. 100 years, more than 150 years back, 120 years back it emerged. Okay. So this is a Pelian type of volcano, the most violent of all. Okay. So Pelian, Mount Pelée is there in the Caribbean Sea. You can see, I have given you the map. The Martinique Island over there, only say Mount Pelée is there. Okay. So this Mount Pelée in the Martinique Island, the Pelian volcano is one of the most deadly volcano. Your atlas, no, this will not be there. Okay, it's okay. You can just write it down. Here it is a Mount Pelée. You can mark in your atlas if you have. Okay, so the Martinique. In the northern part of the Martinique, you have Mount Pelée. Let us say they will not ask you all these things, but still I have given you just northern part of Martinique Island in the Caribbean Ocean. Another important volcanic site is Pacific Ring of Fire. Have you heard this word? It is there in your NCERT. Okay. So Pacific Ring of Fire means what? Pacific is an oceanic plate. Since it is a heavy and oceanic plate, around it there are so many other oceanic plates and other continental plates. So it keeps on subsiding under them. So because of that, continuous volcanism is going on around Pacific Ocean. Pacific Rim of Fire is also say because around Pacific coast, always eruption of volcanoes happen. So it is Pacific Ring of Fire or Rim of Fire, you can see. So I have given you the list of countries. You have to remember, you have to read it before the exam. They may simply ask which of the following countries it touches. See, it will be there. It is not there. Yeah, it is there. List is not there. You can write it down. You can write it down fast. Your 14 countries are there. If it is not there, there is a space. You can write it down. Online students, you can also write it down. The countries around Pacific Ring of Fire, very important, can be asked in the exam. If you want to go and use the washroom, you can just go and come back. And because after 2.5 hours, we'll give the break. So it's a democracy. Everybody will have a different opinion. Okay. If you have too much of urgency. So you are doing first time.
Yes, sir.
You should come for foundation. Okay. Okay, you take a 5 minutes of break and come. Okay, 10:55. You come back in the class. Everyone. ब्रेक तो ठीक है 5 बजे दे देंगे आपको ठीक See, this revision, once you come into the speed, if you break it, then again after 20 minutes you'll feel. So you have to be little bit strong, okay? Little bit you have to push, little bit. Have you heard Mike Tyson? Okay, Mike Tyson, how he does his workout, why Mike Tyson is Mike Tyson? He says people start counting the push-ups from the start. Okay, I don't start counting push-ups when I start doing from the start. The time when my body says you have to stop doing push-ups, from then I start counting my push-ups, 1, 2, 3, 4, like that. Because of that, he says I am Mike Tyson. And he has those specific number of push-ups. He will start counting only when his body says no, you cannot do more push-ups. From then he will start counting the push-ups. Okay. So like that. You have to push a little bit. Done? So this is the Pacific Ring of Fire. There are so many volcanoes are there. And this question is very probable question because one of the most important thing is there are so many countries, so UPSC knows very few candidates will remember the names of the countries. This is the only reason they will ask this question again. Like Mediterranean Sea. We ask Mediterranean Sea question because there are 22 countries and UPSC knows that nobody remember all 22 names. It asks what are the countries around Mediterranean Sea. Similarly, Pacific Ring of Fire, they can ask the question, which of the following countries the Pacific Ring of Fire touches? Okay, so these 14 countries, we must know their names. Trenches. Yes, you have to remember. Yeah, see, trench, what is a trench? See, wherever convergent plate margin is there, oceanic plate subducts under the continental plate. Okay, so see, when a depression is small, you call it as a गड्ढा. तो गड्ढा है. ये समंदर में सबसे बड़ा और लंबा गड्ढा है. इसको ट्रेंच बोलते हैं. Understand? So it is a long, narrow and deep. The trench. So it is a continuous for entire length of the plate. You have a trench. Trench में भी एक deeper part होता है. Trench, you know, the depth of the trench is not same everywhere. If you have such a big gadda, long big gadda which is for thousands of kilometers long, depth is not same everywhere. Somewhere it is the deepest. So that deepest point is known as a deep. Have you heard Challenger Deep, Mariana Deep? Okay. So that is the deepest part of the trench. Understanding? Okay. So distribution of volcanoes around the Pacific Ring of Fire is one of the very important. See, Mediterranean Sea volcanism घर पे जाके करो आप क्या क्या है. Mediterranean Sea में बहुत volcanism होता रहता है. ठीक है. There are so many faults and there are so many volcanoes. तो Mediterranean Sea में कौन सा एक्टिव volcanoes है वो देखो. ओके. पैसिफिक ओशन में जापान के आजू बाजू में कौन सा एक्टिव volcanoes है वो देखो. एंड मेडिटेरियन ओशन में एक्टिव volcanoes है जो सालों में आते रहते हैं. दूसरा हमारे इंडियन ओशन में आई थिंक इंडिया में अपना एक ही है बस अंडमान निकोबार में. okay, वो एक वोल्केनो है बैरन आइलैंड. पैसिफिक ओशन का तो हमने दे दिया है. मेडिटेरियन सी में कौन से एक्टिव वोल्केनोज है? अराउंड जापान एंड अराउंड साउथ ईस्ट एशिया एक्टिव वोल्केनोज. बस इतना करो, इससे ज्यादा तो नहीं पूछेगा. दो चार नाम, फेमस नाम जो बार बार आते रहते हैं, दैट यू डू. तो ये पैसिफिक रिंग ऑफ फायर तो हमने देखा, प्लेट कैसा ब्रेक होता है देखा. वो बताते बताते मैंने आपको छोटा कंसेप्ट बोला था, हॉटस्पॉट. यू रिमेंबर द हॉटस्पॉट? So not necessary that convective current will be able to break the entire plate. It may just break the small point on the plate, and from there lava can come out and create a volcanic mountain. So that is called as a hotspot volcano. Okay. So hotspot volcano creates many mountain chains. See, plate is moving continuously, और नीचे से जो volcano आ रहा है, it is creating hole. So after every period of gap, it creates a hole and create a mountain, new mountain. So like that, you have a chain of mountain. Okay, on a particular plate, you can have a chain of mountain. This is because of hotspot volcano. Hotspot volcano can create chain of mountains by creating small holes, or it can completely tear the plate and create a fracture on the margin of the plate. In case of India, that happened. Our Deccan Trap has formed because of the fracture created by the hotspot volcano. Have you seen the laser cutting? Laser cutting कैसे होता है? So laser से आप होल भी बना सकते हो and laser से continuous कट भी मार सकते हो. तो सेम इंडियन प्लेट के केस में एक continuous कट बैठा वेस्टर्न साइड पे, and from that lava came out and Deccan Trap was formed. Here, in case of Hawaii, Hawaii Island in the Pacific Ocean, mountains were formed because of hotspot volcano. So hotspot volcano and the chain of mountains, they talk about in which direction plate is moving. See, the maximum number of mountains, that direction plate is moving. Understanding? So the use of hotspot volcano is to identify which direction plate is moving. So Aleutian Island is also one of the place where we have a hotspot volcanoes over here. India also near Reunion Island near Madagascar, you have hotspot volcano where it fractured the Indian plate. Understood? Okay. So volcanoes are of, as we have seen in the rocks, volcanoes can be intrusive, extrusive. Okay. So volcano, you get solidified under the crust of the earth, we call it as a intrusive. On the surface, if it gets cooled, we call it as a extrusive volcano. Okay. So different types of volcanoes and fissure type of volcano. Okay. So in case of India, there was a fissure type of volcano, and volcanic landforms are formed because of volcanoes getting cooled either on the surface of the earth or below the crust. So different landforms are formed. Okay. So I have given you the list of landforms, what it is called, like locolith, topolith, batholith, thycolith. Okay. So these are the different intrusive landforms. They can be asked in the exam. क्योंकि ये नाम बहुत कंफ्यूजिंग और बोरिंग से नाम है. लोको किसको बोलना है, फोको किसको बोलना है, पोपो किसको बोलना है, टोपो किसको, कुछ भी नाम से हमारे लैंग्वेज के नाम नहीं. तो यूपीएससी को पता है बच्चे बोर हो जाएंगे, परेशान हो जाएंगे, इसको कोई ध्यान में नहीं रखेगा, तो इसको पूछते, तो इसको आपको करके जाना है. ठीक है. तो लोकोलिथ, फैकोलिथ, सिल्स, डाइक्स, बैथोलिथ, few names you should remember. Okay. So exam के पहले बस इसको देख लेना. So whatever volcanoes are there, the size of the volcano, the content of the lava, the periodicity of the eruption, the intensity of the eruption, okay, it creates a different types of volcanic cones. Some volcanoes are acidic volcanoes, some volcanoes are less acidic volcanoes. Somewhere ash content is more, somewhere lava content is more. So different types of cones are formed. So volcanic cone formed because of ash is called as a cinder cone, or it is called as an ash cone. So what happens over there? When any volcano bursts, volcanic rocks will come out, the heavy material will set first. Agree? Ash will be there in the air. After a few days, slowly it will start settling. So after all the heavy matter is set, ash will just cover the heavy matter, and it will look like a plain volcano like this. So this is called as ash or cinder cone. So quantity of ash is more over here. Okay. Then you have composite cones or stratocones. They are like highest cones. Okay, the height is very high of these volcanic mountains. Composite cones are stratocones. Then you have parasitic cones. See, this is a parasitic cone. Okay, it is taking the volcanic content from the main cone, but it is situating on the same volcanic mountain. So this is called as a parasitic cone. So they have given the different names. This one. See, composite cones, composite means what? Composition of two things. So what is being composite over here? See, pyroclastic material means rock. First, rocks and little bit of ash will come out. That will be covered by the lava. Again, lava will be covered by the ash and rock. Again, that will be covered by the lava. Like that, alternate layer of ash, lava and volcanic rocks will be there. That's why it is called as composite. There are so many things, okay? I am not going in too much detail because we have less time, okay? So then you have basic lava cone, it is called as a shield cone. Okay, so here lava travels very far. like a shield. It creates a shield on the land. Okay, so this is called shield cone. Okay, so these are different types of cones. Then you have acid lava cones. Okay, see, volcano once it's dead, after few millions of years, whatever cinder cone was there, it gets eroded. The ash will be gone, the pyroclastic material will be gone, but at the center of the cone, the pipe was there. There you had a pure volcanic lava. That solid lava becomes like a solid rock. And that central part of the volcano remains, it stands. So it looks like a ship is standing there. So it is also called as a ship rock. Or it is called as a lava plug. आपने देखा होगा शैंपेन के बॉटल को प्लग होता है या वाइन के बॉटल को प्लग होता है. So similarly they call it as a lava plug. Okay, so this is nothing but a volcanic lava which has been solidified. Surrounding cone eroded, it is gone. The plug is remained. Okay, so these are the different things. Then you have a depressed forms like craters and caldera we have seen. They are called as the depressed forms of the volcano. Volcano also get depressed. Okay, so it has a different forms. Depressed forms. Okay, they call it depressed forms. Then you have a geysers, fumaroles. So geysers, you know, have you been to Kedarnath, Badrinath, some pilgrim places? I know your age is not that high that you go on going to pilgrim places, but still, many of might be trekking enthusiasts or Himalayan enthusiasts might have gone to Gangotri, Yamnotri, Tapovan, Kedarnath, Badrinath. If you go there, you will have so many hot springs. Many of them are called as Parvati Kund. Many of their Parvati Kunds like that. Okay, so how these hot springs are formed? How the geysers are formed? They have medicinal properties. Okay, specifically in Maharashtra, the place is called Vajreshwari. Okay, there's the Ganpati temples are there, and these hot springs they come from the some certain depth, and they have high content of phosphorus. You see, the water is like yellowish in color, and the huge kunds are formed there. The water is yellow and it is little hotter than the warm. So people come there, and there are Ganpati temples they have created around the kund. So people with the skin diseases come and they are supposed to take bath in that kunds, and they are supposed to stand there, and it gets cured. Like many people are sent there, like people who have no skin disease like psoriasis, or people have arthritis. Even the bone diseases gets cured because this water have medicinal properties. So ancient Indians in our places, they identified such places and they created temples. So many people get benefited. Okay, if you see just a small spring, hot spring, I tell you take a bath, you will not take it. But if I say, oh, it has a spiritual benefit, you know, you take a bath, God will be happy. Then you go and take the bath. Okay. So because of around such places, they have created a lot of temples like Kedarnath, Badrinath, and Gupta Kashi, and so many places you have hot springs. So these hot springs are nothing but magma is very close to the source of water. Because of that, the heat is going there and boiling the water. Sometimes the magma content gets mixed with the water. As I told you, phosphorus is there getting mixed with the water, and water has some medicinal properties. Okay, so geysers and fumaroles, okay, hot springs. Geysers, what happens? Continuously, water is not continuously coming out. After a few interval, it will just come out. It will fly in the air and again it will go. Because what happens? A steam, a steam pushes water upside. An entrapped steam pushes water upside, so it will come. Again it will go down. After 10-15 minutes, again it will come out like that. And in hot spring means continuously water is coming out. Okay, so these are the different things. Then you have fumaroles. Okay, how it's? So it is a simple thing. What is happening? Water is a water aquifer. This is a magma chamber. So heat is being received by this water aquifer. steam is getting formed. Steam is getting entrapped here. When the pressure is very high, like a pressure cooker, pressure is very high, steam will try to come out and it will push the water up and steam will come out. Okay. So this is a geyser. Okay. So you have geyser, then you have fumaroles. So here emission of various gases happens along with the water vapor. This is a last sign of that volcano is active. After that, volcano might be dead. Last sign that active volcano was there. Okay, so you have a fumarole. So fumaroles, they have different gases. Volcanoes have different gases. So gases like hydrochloric acid, hydrogen sulfide, nitrogen, ammonia, carbon dioxide, these are gases which are there. Nitrous oxide is also there. So many types of gases are there in the volcano. Okay, so you guys take a break now. Okay, I'll see you 5:25. 20 minutes break. Okay. So there are three types of mountains: volcanic mountains, fold mountains, and fault mountains. Okay, so from UPSC prelims point of view, they can ask the examples of a fold mountain, fault mountain. They can ask the examples of block mountains, volcanic mountains, or they can simply ask about the process of mountain building. We can give you one or two options. So we know how volcanic mountains are formed. We know how fault block mountains will see. This we have seen how volcanic mountains are formed. Like slowly, the magma comes out and the volcanic mountains are being formed. Okay. The most important mountain which goes on forming for millions of years is the fold mountain. So fold mountains are formed out of collision of continental plate and a structure called as a geosyncline. Okay. So geosyncline is one of the important concepts for your prelim point of view. What is a geosyncline? Geo means earth, syncline means depression. So depression in the earth. So that depression might be on the single plate. Okay, within the single plate you might have a deep depression. You can call it as a geosyncline, or before two plates are meeting with each other, there is a gap between them. Before meeting, there is a gap between them. That also you can call it as a geosyncline. Okay, so geosynclines are the cradle of fold mountain. Okay, जहाँ पे fold mountain पैदा होते हैं, so they are called as a cradle of fold mountain. So what happens here? Two plates are traveling towards each other, two continental plates. So before they completely meet each other, okay, the gap between them is filled with lot of sediments. Okay, so as these two plates are coming towards each other, these sediments get compressed. Okay, and when these two plates they come closer to each other sufficiently, these sediments start rising. And finally, the sediments completely rise, and along with that, edge of these two plates also fold and it rise. Continental plates we are talking about. So that you call it as a fold mountain. Understanding? So like this mountain building process starts. So here subduction does not happen. Okay, this is little bit of subduction, not full subduction. Okay, so like this mountain is being raised. So this is called as a fold mountain. So it will be there, I think, little bit. 29. Okay.
So this can be between two oceanic plates as well as two continental plates.
Fold mountains are formed only between two continental plates. Okay. So characteristics of geosyncline. What is the characteristics of geosyncline? So it is a type of long narrow depression. In that depression, gradually sediments keep accumulating. So gradual sedimentation happens in the geosyncline. Okay, it is a long and narrow. So after it is completely filled, what happens? Sedimentary rocks also form there. So you know Himalaya is also one of the fold mountain. So Himalaya is completely made up of sedimentary deposits. Have you traveled the Himalayas? it's very fragile, and it is not a continuous. Okay, if you go to the central India, you go to the Western Ghats, they are continuous, igneous, very hard. It is very difficult to break. But here, Himalayas are very easy to break. They will simply dissolve into the water. They are called as a mud mountain because they are completely made up of sediments. Okay, so one of the important reason behind them is because the sediments which are from which it is found, they were created during the time of geosynclines. So inside geosynclines, sediments were formed. Okay, out of them a mountain has been formed. So there are 4 ancient geosynclines. Right now there are mountains. So at the Rockies there was a geosyncline. At Ural in Russia there was geosyncline. Tethys was a geosyncline. Okay, Circum-Pacific region geosyncline was there and it's still being formed. Okay, so wherever you have ocean and continental margin, geosynclines are bound to form. Okay, because from continents, rivers are going to come, they are going to deposit their sediments in the ocean or the margins of the continent, and geosynclines slowly keep forming there. Okay, so wherever you have a continental and oceanic plate margin, definitely it is a destructive plate margins. Okay, wherever continental and oceanic plates meet, most of the time it is a destructive plate margin. So it is bound that oceanic plate is going to be consumed completely after some time. Okay, and 2 continental plates are going to meet afterwards. So geosynclines are bound to form there. Okay, so this is one of the reason. Okay, why there are ancient geosynclines everywhere. So characteristics of fold mountain, if you see, they are the youngest mountains. Why they are youngest mountains? They are continuously growing. See, one of the sign of being young is you are growing. A person stops growing, that means he is getting old. So these mountains are continuously growing. Every year 8 centimeter, 10 centimeter height is growing. So you are calling them as the youngest mountain in the world. Okay, then there are old mountains, okay, whose height is not growing, height is going down because of erosion. Okay, so like you have Aravallis and all, so they are old mountain, they are not young mountain. But Himalaya is a youngest mountain because its height is still rising. Okay, so the characteristics of the fold mountain, they are continuously growing. They are long, they are narrow. One side is concave, another side is convex. Because it is formed because of the pushing of sediments. So the side where push will be more, that will be concave. Another side naturally will be convex. Okay. So generally it has a convex and concave side. Length is longer, width is smaller. Okay. Found on all continents, and they are called as the true mountains. Because they have formed out of a long process of mountain building, they are called as a true mountains. Okay. Sometimes fold mountains are formed because of the meeting of oceanic and continental plate as well. Sometimes it happens, but it is a rare happening. Specifically in the Rockies region it has happened. So Rockies, what has happened in the Rockies? So oceanic plate has underwent the North American continental plate. When it underwent the North American continental plate, again it rose after 400 kilometers. It did not went like that. It did not go like this. After 400 kilometers, it resurfaced and it pushed the crust of the North American continental plate. Because of that folding happened, and because of that fold mountain, Rockies also have a fold mountains. It has a volcanic mountains, it has a fold mountains, it has a block mountains. That's why Rockies are called as a I forgot the name, I'll tell you. So Rockies is a constellation of all the types of mountains. Okay. So in India, you have so many fold mountains. Like whatever mountains are there in India, Eastern Ghat, okay, and Aravallis, Satpuras. At one point, they were fold mountains. When India was a part of Pangea, India was a part of Gondwana land. When they were formed as a fold mountain. Okay, but now the characteristics of being fold mountain has been lost, and in between they underwent faulting and erosion. So we don't call them exactly fold mountain or exactly fault mountain. So they are mixed. But Himalaya is a true fold mountain right now. Okay, so Himalaya is the only fold mountain which is called which is growing right now, which is a true fold mountain we have. Rest are combination of fold and fault mountains. Western Ghat is a fault mountain or block mountain. Okay, so what is a block mountain? So Western Ghat is an example of block mountain. So block mountain is not a true mountain. So what happens? We have seen process of erosion. Erosion, continents are warping, breaking of continent happens. So what happens? A little bit part of continent is being broken. So this broken part is either pulled down or pushed upward. If it is pulled down, the part which has been pulled down, it looks like a valley. The valley is called as a horst. Okay, sorry, the valley is called as a graben. Okay, if it is pushed upward, then it is called as a horst, it looks like a mountain. So that's why it is called as a block mountain, because the block of a continent is rising because of pushing and pulling and faulting. This is called as a block mountain. So fold mountains are the results of compressive force and block mountains are result of tensile force. Okay, because of the tension, breaking is happening. So they are result of tensile force. Fold mountains are the result of compressive force. Understanding? Okay. So here is the process how these block mountains are formed. Okay, this is how a block is adjusted, and this is you have a horst. This is how Western Ghats are formed. Understanding? This is how the Western Ghat that we see today is a result of pushing out a small part of the block. Okay, so you have a horst, and the value of the Western Ghat is called as a graben. Okay, so Great Rift Valley is also example of graben. Great Rift Valley, we have seen Africa's Great Rift Valley is an example of graben. Okay, there also faulting is happening. Okay, the nascent sea is going to form, we have seen. Okay, so these are the examples of block mountain. Okay, Black Forest, Vindhya, Satpuras. Okay, so these are some examples of block mountains. Himalaya, Ural, okay, Atlas, Alps, they are the examples of fold mountain. So you should know which are the fold mountains, which are the block mountains. A few examples you should know. Okay, so this is all about endogenetic processes of epiorogeny, orogeny, plate tectonic, diastrophism, volcanism, and all other processes. Okay. Everybody has got something about, okay. Now, next is the exogenetic processes. Exogenetic processes means force is applied from outside, that we have seen. Who is applying the force? Water is applying the force, sunlight is applying the force, wind is applying the force. So these are the different agents which apply the force. So diastrophism creates the structure, and exogenetic processes, they shape the structure. Understand? Diastrophism, volcanism, they will create the mountain, but wind, water, they will shape the mountain. Okay, so exogenetic agents, they act mostly as a shaping agents. Understanding? Okay, so exogenetic agents are different types. So what is the energy that drives the exogenetic agents? Heat of the sun, sunlight. Okay, kinetic energy of a wind. Okay, then there can be tectonic forces. They can create a gradient. Because of that, gravitational force can also be act. So gravity is also a kind of exogenetic force. Okay, so gradient created by the tectonic factors. Okay, stress, either because of gravity or temperature, they are driving the exogenetic forces. So this NCERT, there is one small diagram I have given in your notes. It's very important. Okay, so what these exogenetic forces do, they do the work of denudation. So they are called as the denudational agents or denudational processes. Every denudational process has some force driving behind. So this chart is very important. इस पे बहुत सवाल बन सकते हैं prelims में. Okay, so first is the weathering. What is the force which is driving the process of weathering? Gravitational force, then molecular stress and chemical action. Weathering is the process. Wind is not involved. See, in the weathering, transportation is not involved. So any agent which does transportation is not involved in the weathering. Whenever transportation comes, it is called as the erosion. Weathering is the in situ degradation of any material. So three basic processes: weathering, mass movement and erosion. So weathering, gravitational, molecular stress and chemical action. For mass movement, gravitational force. Only gravitational force is responsible for mass movement. And the last, erosion, kinetic energy. इस पे MCQ बन सकता है, ठीक है? Important. So weathering, if you see, so it is on-site disintegration of any material. On-site disintegration. Material does not get transported. Okay, now you can see this rock. This rock, with the action of water, with the action of ice, with the action of temperature, rock has been disintegrated and it has fallen in the same place. That is why it is called as in situ, on-site disintegration of anything. So weathering is very important for the formation of soil. Without weathering, soil formation is very difficult. Okay, so this is the process of weathering. So there are different types of weatherings. What are the different types? Chemical weathering, physical weathering, biological weathering. These are the different types of weatherings. Chemical weathering, there are 4 types of weathering, 5 types of weathering. Solution, carbonation, hydration, oxidation, reduction. Okay, so very simple. What happens in the weathering? Because of the action of oxygen, water and heat, they together dissolve the minerals in the rock, and rock become very fragile. When rock becomes fragile, it gets disintegrated. Okay, like see, pockets will form in the rock where minerals will be dissolved. So this is a chemical action. So rock has a potassium carbonate that will get dissolved in the water. Okay, so water, air and heat, they act. So solution means what? Water acts upon, pure water dissolves the minerals of the rock. Rock becomes fragile. Carbonation means what? Carbon dioxide gets dissolved in the water, and water is nothing but a weak carbonic acid. And that weak carbonic acid reacts with the calcium in the rock. It forms calcium carbonate and it forms pockets in the rock. Because of that, rocks become fragile and they disintegrate. Understood? Okay. So this is a solution and chemical action. Then you have a hydration. Have you heard the word dehydration? What is the dehydration? Body loses the water. Loss of water. Opposite of that is hydration. What is the hydration? You drink too much of water. That is hydration. Excessive water. So here what happens? Rock drink excessive water and it bursts. Kind of burst. Have you seen temples जहाँ पे नारियल फोड़ते? नारियल फोड़ के फिर वो एक रॉक पे पानी डालते रहते लोग. तो 2-4 साल के बाद क्या होता है ना, जहाँ पे वैसे नारियल का पानी डालते रहते हैं ना, वो रॉक इट स्टार्ट स्वेलिंग. और टेम्पल का जो भी दूध जाता है, पानी जाता है, वो जो नाली होता है, वो अगर रॉक का बना होता है, it will swell, it will, a kind of rock will swell and it will start breaking. Okay, so because this happens because of excessive intake of water by rocks. So it happens naturally in the various places where rocks have a tendency to take the water. Okay, so hydration is there, it's one of the processes that we have. Next is the oxidation. ऑक्सीडेशन मतलब जंग लगना, हिंदी में सबसे सिंपल. ओके, जैसे आयन होता है, रॉक में आयन कंटेंट अगर होगा, सो दैट विल रस्ट. सो एक्चुअली रॉक will not look like a rusted iron, but its color will change. So yellow color will be there, it will be brownish color. Okay, so this is called oxidation. Now same rock which has been oxidized, if it goes under water and contact with the oxygen goes, it will undergo reduction and it will look greenish blue color. This is called reduction. So oxidation and reduction are also responsible for the withering of rocks. Okay, so these are the chemical withering of rocks. Then you have a mechanical withering. Mechanical withering means what? Stretching, squeezing. Okay, a stress is being created. It's called mechanical withering. So it can happen because of loading, unloading, temperature change, freezing, thawing, salt weathering. So different types of mechanical witherings are there. Okay, so you can see this tor. Okay, so this tor is a result of mechanical withering. So initially the rock was like this. So what happens, you know, rock or soil is a bad conductor of heat. Have you been to the desert? Anyone? कोई desert पे गया अभी? Have you been to desert? Okay. So if you go to the desert in the afternoon, you see the desert sand on the top is very hot. But just you put your hand just below 4-5 centimeter down, it's very cold. See in the border movie, Sunil Shetty movie, you know, recently the character he played, Bhairav Singh, he died recently. Okay, so the entry of the Sunil Shetty in that movie, if you see, he is like sleeping under the sand. Okay, all sand is there on his body. So actually in the desert, what happens? On the top, sand is very hot. You will feel like very hot temperature. But just 4-5 centimeter below, it's very cold. It's like your hand will feel like your air conditioner. So that's why desert insects and animals, during the daytime, they will always dug and they will go inside the sand. On the top, they will not be there. So this is because sand is a bad conductor of heat. Rock is a bad conductor of heat. So what happens here is, because of sunlight, the outside of the rock heats. Outside layer heats and gets expanded. But the layer below that, it remains same. It does not expand. So outside layer keeps on heating and contracting, heating and contracting. After some time, cracks develop in that. And because of that, the edges of rocks disappear and rock looks like this, circular. This is called as a tor. Understanding? Okay. So this is a kind of mechanical disintegration. Next, you have a freezing and thawing. So what happens in the cold areas? Daytime water gets accumulated, nighttime water gets accumulated and gets converted into ice. You know, water when it becomes ice, it expands, volume increases. Because of that, it creates mechanical pressure inside the rock and rock disintegrates. Okay. After that, you have a salt weathering. Salt weathering means what? You know, a region has a lot of salt content in the water. That salt content gets accumulated in the rock, and kind of salt structures form in the rock, and in the fractures salt gets accumulated and rock starts expanding and rock breaks. Understood? So this is called as a salt weathering. समझ में आ गया? This is a mechanical weathering. Then the last one, you have a biological weathering. Biological weathering means by animals, plants, and you and me. We are also doing a lot of weathering. Okay, so we are building houses, we are building constructions, we are going for tourism. For us, roads have to be built. Okay, hotels have to be built. So we do lot of weathering, very fast. Anthropogenic weathering is the most dangerous of all, fastest of all. So you can see plant roots, they are doing weathering. Little animals, they will burrow the rocks. Okay, rats, then rabbits, foxes, okay, owls. So they will do this type of weathering. They'll create pockets in the rock, grasses. Okay, so this is called as a floral or faunal weathering. Understood? Okay, so this weathering is one of the important precondition for the soil formation. Soil cannot be formed without weathering. See, soil, don't take soil very lightly. It takes millions of years to form the top layer, 3 to 4 inches of top layer. Okay. Once it is lost, again it has to form in few million years. Air you can purify, water you can purify. You stop dumping the dirty water in the river. You stop the factories dumping water in unclean water in the river. It will be cleaned in 2-3 years. Automatically river will be cleaned. But soil, if it is destroyed, millions of years it cannot come back. That's why I told you that FAO, UNCCD, they are saying that everything, you are paying attention to everything. Nobody is talking about soil. Okay, because there are so many vested interests in the soil. Nobody is talking about the soil. No conferences. Just now they have started talking about the soil because they are saying, forget about climate change, everything. You will die because just your soil is not there. 60 years of only harvest has been left there. After 60 years, no food. You cannot grow food. Because soil does not have any, soil will be sand, organic matter will be completely gone. So you will use biotechnology, okay, 5 years extra. You will use hydroponics, okay, 2-3 years extra. Then what you will do? You have nothing in your hands. So they are saying it's very dangerous situation. Okay, because it takes millions of years for the geographical processes to go on. So that is why this weathering is very important part of soil formation. Okay, so significance of weathering. What is the use of weathering? Soil formation, as I told you. Then enrichment of the soil. Enrichment means what? What happens because of the weathering? Let us say one particular mineral quantity is more in the rock, and unwanted mineral quantities are also there. So what may happen? These unwanted mineral quantities may go away from the rock because of weathering. And whatever mineral quantity, whatever desired mineral you want, that may remain. So ore formation can take place. Soil enrichment can take place because of the weathering. Okay. So these are the different benefits of weathering. Ore formation means, rock, let us say rock has a gold content in that. But you cannot take out the gold until and unless everything is withered. Okay, so once that rock is withered, it becomes like a soil. It will be easy for you to take that rock, to heat it and take a gold out of it. So ore formation has been, ore means what? Khadan. So ore has been formed there. And the important agent is withering. So next, a geomorphic process or exogenic process is a mass movement. So I have given you in a very simple format. In your NCERT there is a whole chapter. No need to read the entire chapter. 2 pages में मैंने उसका एक chapter आपको बना के दिया है. So what is a creep? Okay, I have a small video if you want to see. So this is called as a mass movement. Only gravity is responsible for this. Only gravitational force is responsible for it. Landslide is a part of mass movement. Landslide is a part of mass movement. Yes, Himalayas. Okay. So weathering may help in the mass movement, but it is not necessary. Weathering is not necessary for the mass movement.
Wave means water पे slant होता
No, in the creep, what happens? Slowly, what will happen from the mountain? See, mountain has lost grasses, all forest, soil is very loose. So slowly, it will start creeping down. Soil, stones, everything will start creeping down. हाँ, रेंगना, creep मतलब रेंगना. Slowly, they will start coming down. If it is lubricated by the water, then it will be little faster. Then it will call as a, again it will call solifluction. Okay. So extremely slow. Okay, glacier and rock, they creep. ग्लेशियर, आप ग्लेशियर पे जाओ, वहां पे खड़े हो जाओ, आपको नहीं पता चलेगा ग्लेशियर मूव कर रहा है, बट ग्लेशियर इज एक्चुअली मूविंग. एवरी ग्लेशियर इज मूविंग, बट यू डोंट कम टू नो. दैट्स व्हाई इट इज कॉल्ड एज अ क्रीप. ग्लेशियर क्रीप्स. Okay, rock also, small rocks, they creeps. Okay, if they are on the slope, slowly they creep. Slowly solifluction and so many things. Please read this. Very simple. एक line में मैंने दिया है. Okay, in exam they may ask, when you have a rapid, you have a slow mass movement, rapid mass movement, earth flow, mud flow, debris avalanche. Landslides is also part of mass movement. So in under landslide you have slump, debris slide, debris fall, rock slide, rock fall, everything. Okay, so these are the different types of mass movements. Okay, तो मैंने आपको notes में दिया है, उसको एक बार देख लेना. Okay, so any doubt up till here? Any doubt up till here? So I think since this is a very factual, okay, very factual, so it's not very difficult. So we will go quickly go through landforms. Okay, factual है, UPSC पूछता रहता है, so quickly we'll go through the landforms. Okay, last part of the chapter. Okay, is a landform. So landform is a kind of a form that land takes. Whatever might be reason, mostly the reason is external agents. So because of the action of the external agents, a land has taken a particular form, which is clearly distinguished from the surrounding areas. So you are calling it as a particular landform. So different agents work differently and they create different types of landforms. Okay. So basically landforms are of two types. Depositional landforms, or sorry, first erosional landforms and then depositional landforms. So landform is a process of erosion. Erosion is a part of transportation. And wherever transportation is involved, kinetic energy is required. But whenever you have energy, energy is not unlimited. Energy is very limited. So when energy is finished, the speed of the erosional agent is going to be reduced, and whatever they are carrying, they are going to deposit it. So once they deposit, you have a depositional landform. So same agent is going to create erosional landforms, and when the kinetic energy is lost, it is going to create depositional landforms. Okay, so running water, wind, glacier, these are the major agents, okay, of erosion. Out of them, running water is one of the major agents. The strongest agent of erosion is a glacier. Out of all, glacier is the strongest agent of erosion. बाकी के भी है, but glacier बहुत strong erosion करता है because of its sheer weight. Glacier is a very strong agent of erosion. Running water is also very important agent of erosion. Okay, you have seen the rivers, you have seen the streams. Okay, so देखो river form कैसे होता है, इसका process कैसा है river form होने का. See, water erodes in all forms. Now rainfall is happening, a small droplet is coming and it is creating an imprint on the soil. You will have a beautiful smell of a soil as soon as there is a rainfall. Nice smell. You know why there is a beautiful smell of this soil? You know why soil smells very beautiful after rainfall? So yes. No. See, there are some certain plant oils which are there in the soil. There are certain bacterial spores inside the soil. Once a water falls on them, they gets activated and they start smelling. That's the smell of the soil. इस पे थोड़ा सा घर पे जाके research करो. UPSC can ask this question. That's what I'm saying. Why soil smells very beautiful after a rainfall? What is the content of the soil that smells? What is the reason behind the perfume? You should know this, okay? So, as soon as the drop of the rain hits the soil, on a very minute level, the soil gets displaced. A dust smears in the air. That is also kind of erosion created by the droplet. That is the first erosion created by the droplet. Again, little bit of extra rainfall leads to the little bit of saturation of soil. You get a mud. Further little bit of extra rainfall, the particular area gets filled with the water. And the water starts flowing along with the soil. You see the rainwater flowing, it will look brownish in color. So the huge area, water will start flowing, the brown color water. We call it as a sheet erosion because it covers large area on the surface and collects the soil on the topsoil and it starts flowing with that. It's called sheet erosion. Again, a bit of extra rainfall. The running water starts accumulating in the small channel. We call them as a rills. You know, children, they'll when you're small, 4 or 5 years of old. How many of you have stayed in village? I don't know. But if you go to the village, children just a small rills flow in the rainy season behind their houses. They will put their boats, small boats, paper boats. So small rills are there. You try it one more time now, okay? So these rills are because of the extra accumulation of water. Further, you have an extra rainfall. These rills become big and they erode bigger. And the eroded lanes are called as gullies. Further, 2-3 gullies will come together. The combined gullies, there will be known as ravines. Have you heard चंबल ravines? चंबल के डकैत फुलन देवी का नाम सुना है सबने? तो चंबल के ravines बने इसके वजह से. दिल्ली से आप नीचे जाओ, एमपी क्रॉस करो ट्रेन से, आप पूरा चंबल से जाओगे, ravine आपको दिखेगा ट्रेन से. Okay, so this is because of the erosion by the water. It was very difficult to catch that woman, फुलन देवी, क्योंकि वो पूरा इतना भूल भुलैया बनाया था उन्होंने. वो ravines they are like भूल भुलैया. पुलिस अंदर गए, पता नहीं डाकू किधर है, पुलिस किधर है. पुलिस इधर ढूंढ रही, डाकू उधर है. वो पुलिस 15 पुलिस अंदर चले गए, 15 के 15 गुम हो गए खुद. डाकू तो मिले ही नहीं और 2-4 लोगों को डाकू ने पकड़ के ले लिया. So that was the condition. So that is the condition of Chambal. So finally she herself surrendered. Okay. So these ravines are bigger and little deeper. Okay. And they create badland. It's also called as a badland topography. Okay. Where you cannot walk. So finally these ravines, again let us say few ravines come together, then small rivulets are formed. Rivulets. एक छोटे विलेज में एक छोटा सा नाला बोलते हैं हम उसको. Then the small rivulets they will come together. A small river or a tributary will form. And again it will grow in the size, merge with many other small rivers, and a big river will form. This big river will further erode the particular place and it will create a big valley. Like this, a volume starts increasing and erosional landforms also start increasing. See, this is how, see, you can see how big boulders are being flown in the river. The speed of the river, see the kinetic energy. It's very difficult to take out these big boulders, but just at the base of the mountain, because river has just crossed the mountain, it has a very high speed. So at the base of the mountain, it can carry such big boulders. You won't be able to stand here. Okay, though the depth is not much, it's very difficult to cross such river. Okay, so running water has so many types of, let us say, landforms. They are called as the fluvial landforms. Sheet erosion. See, what is the meaning of sheet? Sheet, you know, paper sheet you have seen. So sheet is nothing but a thin paper which it can occupy large area. So at that, like water also, water with the size of sheet occupies large area and dissolves soil and carries that soil along with itself. We call it as a sheet erosion. A large area is covered by the water. Not a small channel, but large area is covered. And the water is being, the deposits are being, soil is being dissolved in that. Deep nahi hoga. Oh, surface pe hoga, surface. It is not deep. जैसे flood आता है. See, flood water spreads few 100 kilometers. So it creates a sheet on the land. Floodplains. Floodplains only. Okay, anyways, that will come ahead. We'll have all the landform. We'll come there. No, don't get confused. Okay, we'll come there. One by one, we'll come there. Okay, don't get confused. So river has various fluvial landforms. So here you have a river valley, potholes, rapids, waterfalls, river terraces, river meanders, so many. So erosional landforms, see, I have given you the list. So like this you have to remember. Which are the erosional landforms, which are the depositional landforms. Because they can be simply asked which of the following are the erosional landforms or which are following a depositional landforms. Okay, names are very important. Which landforms belong to water, which landforms belong to air, which landform belongs to glacier. The names are also very, very important. Understand? Okay. So,
then what is the difference between alluvial and alluvial plains and sea? Or in alluvial plains, river carry alluvial part.
see, sheet is a very basic type of river. Sheet erosion is not done by the river. Sheet erosion can be done by the little bit of heavy rainfall. Little bit of heavy rainfall occurred and let us say a few 100 acres of farms are covered by the water and sheet erosion happened there. Topsoil is completely gone. Alluvial fan means river is carrying the huge amount of load and it is dropped suddenly. That is alluvial fan. Okay. So you have a depositional landforms. So cause of depositional landform is, what is the cause? Kinetic energy is getting reduced. That's why you have a depositional landform. So river, if you see river erosion, let us go to river erosion. So entire course of river can be divided into three parts. Upper course, middle course and lower course. So these three different parts are dominated by different types of landforms. Why different types of landforms? Because kinetic energy is different in the different sections of the river. So where you will have a more erosional landforms? अपर कोर्स में सबसे ज्यादा इरोजनल लैंडफॉर्म हो गई, काइनेटिक एनर्जी वहां पे ज्यादा है। डिपोजिशनल लैंडफॉर्म ज्यादा कहाँ पे हो गए? सबसे ज्यादा लोअर कोर्स में हो गए, काइनेटिक एनर्जी सबसे कम है। एंड इंटरमीडिएट मींस कॉम्बिनेशन ऑफ बोथ डिपोजिशनल एंड इरोजनल कहाँ पे हो गया? मोस्टली मिडिल कोर्स में, वहां पे दोनों टाइप के लैंडफॉर्म मिलेंगे। ओके, सो these three different courses of the river are dominated by different types of landforms. So upper course you see V-shaped valley, interlocking spurs, waterfalls, gorges, all erosional landforms. Middle course meander, erosional as well as depositional landform. River cliff, erosional landform as well as partially depositional. Slip of slope, again erosional as well, plus slip of slope is also depositional landform. So combination of depositional and erosional middle course. Lower course, Hawksbow Lake, flood plains, levees, depositional landforms. पढ़ना है, important है. So is it not written there? Okay, you can write it. कोई बात नहीं, लिख लो जो नहीं है. देखो समझना इंपॉर्टेंट है. सब अभी आप समझोगे तो रिवीजन में भी आपको इजी जाएगा. ठीक है. ओके, so upper course of the river, let us see the landforms at the upper course of the river. So first landform at the upper course of the river is V-shaped valley and interlocking spurs. Okay, so V-shaped valley and interlocking spurs, they are the one of the most important landforms in the upper course of the river. Okay, so you see in this diagram, upper course of the river, the speed of the river is very fast. Kinetic energy is very high. See, when kinetic energy is very high, river is not going to take a big turn. River does not have that much time. Turns will be very fast. So river will swing. So when river is swinging, lateral erosion will be very less. Vertical erosion will be very dominant. Generally, this is the top of the mountain. So here, vertical erosion is dominant. So when vertical erosion is dominant, it will create V-shaped valley. V-shaped valleys are not very deep. They are V-shaped valley. Plus river is swinging like this. So it will create a structure called as interlocking spurs. Most of you might have eaten a non-veg, or let us say non-veg. You have seen the hen claws are there like this. They are called as the spurs. Bird claws, they are called as the spurs. Interlocking spurs means like this. Spurs are interlocked. Okay, so you can see they are looking like interlocking spurs. Yes. Have you, when the Pangong Lake encroachment by Chinese soldiers was going on, you hear the word called finger 5, finger 6, finger 8. So this finger 5, finger 6, finger 8 is nothing but interlocking spurs. Understanding? So the fingers, they are also called as fingers or interlocking spurs. In geographic language, they are interlocking spurs. So you go to the Ladakh. Has anyone gone to Ladakh? Been to Leh Ladakh? If you get a chance, if you want to learn the entire geography, just go to Leh Ladakh. You will learn the entire geography there. You will see each and everything. All the geographic structures, everything. River, valleys, alluvial fans, everything you will see. Interlocking spurs, lakes, oxbow lakes, everything you will see there. very beautiful place. Okay, so near Pangong Se Lake, there are interlocking spurs, which these Chinese people they encroached. So they were not supposed to come to the finger 8, but they came up to finger 8. They were supposed to be only up to finger 4 or finger 6. So they crossed this finger 4, finger 5, and they come to finger 8. So Indian Army was trying to tell them go to finger 4. So that was the news reporter was telling. Encroachment near Pangong Se Lake. Okay. So they are result of swinging of river. Swings, vertical erosion, V-shaped valleys, interlocking spurs. Okay. So these are V-shaped valleys. V-shaped valleys go on widening. Okay. So along with the V-shaped valleys, you have other types of landforms on the mountain. First one is the rapid. Rapid word itself tells that something is going rapidly. So water from these places, they flow very fast. So they are step-like landforms. Can you see there? So they're like step. Have you, like how many of you go to the forest or rivers? I don't know. But if you go, some places you will see step-like landforms. Yeah, there are there in Ganga, many landforms are. There are step-like. So they are called as a rapid. So ऐसे step-like कैसे बना? So what happens? Vertically, rocks of different nature are there on the mountain. Somewhere you have a soft rock, somewhere you have a hard rock, soft rock, hard rock. So wherever you have a soft rock, it gets eroded more than the hard rock. So because of that, you have like a roller coaster ride for the water. Okay, it is called as a rapid. You go to the Kerala, you will have very long rapids, like 100 to 100 meter long rapids. Kerala rivers. Very huge waterfalls in Kerala. All those movies, Bahubalis and all, they are shot there. Okay. So these rapid will, in the latter stage, it will get converted into waterfall. See, now this soft rock has been eroded up till here. After some time, the soft rock will be eroded more. This soft rock will be eroded like this. After some time, this rock will be eroded like this much. After some time, it will be eroded this much. No, it will be waterfall. This rapid will be converted into waterfall. Water will fall like here, like this. Understanding? So these are the waterfalls. Rapids will get converted into waterfall. After some time, what will happen? Now, vertically, this rock has been finished, completely finished, eroded. So, the water will start eroding the side walls. Vertical, now this has a side walls as well. And because it starts eroding the side wall, waterfall will start receding backside. And a structure will be formed which is called as a gorge. So this is a waterfall. It has eroded the soft rock. Now this rock is finished, completely eroded. At the base, a pool will be formed which is called as a plunge pool. Okay, many ads you see, soap ads and all these ads where the model goes and dives into the plunge pool. Waterfall is there. Literal ads. So many ads are there. So they use the plunge pools for. So after this soft rock is finished, waterfall will start eroding the walls itself. And it will start receding backward. And after that, what will form is a gorge. Okay. So here you can see how. So there is a soft rock, hard rock, and below you have plunge pool. Okay. So this is an internal structure of waterfall. This is how slowly, this is rapid. Now rapid is getting converted into waterfall. This is a plunge pool. Now waterfall started receding backward. It will start eroding its own walls. Slowly it will start receding backward. When it will erode its own wall like this, the structure will be formed which is called as a gorge. Understanding? So this is how gorges are formed. Generally it is formed in the hard rock. A rock is continuous in the gorges. It looks like this. ये NCERT diagram है आपकी. Okay, this is a gorge. नहीं अभी तो ड्राई है, इसीलिए फोटो लिया है उन्होंने. ये तो कौन जाके फोटो निकालेगा यहाँ पे? Gorges are the places where people go to die, or they die by mistake. They die. Okay, because if you want to see the beautiful gorges, you go to the Kedarnath. Kedarnath, you go, in between you will see beautiful waterfalls, rapids and gorges, so many gorges. These travel enthusiasts can try this, okay? So this is a gorge. So gorge generally, if you see, the width of the top and width of the bottom is same. The rock is the same, single rock. Okay, so this is gorge. Sometimes what happens, horizontally bedded rocks are there, long rocks. So there, a gorge with an extended length has been formed. So this is few hundred kilometers long gorge. It is called as a canyon. This is the only canyon in the world. US में Mississippi River पे Great Grand Canyon. It itself took few crore years for the formation. So only structure. You can see the fellow sitting there. So horizontally bedded hard and soft rock, they are eroded at different rate. That's why these canyons are formed. The Great Grand Canyon. No. This is not just because of waterfall. This is a very big gorge. Not just because of waterfall. Waterfall से तो छोटा-छोटा gorge बनता है. This is called as canyon. Extended form of, very extended form of gorge. So definitely there will be multiple waterfalls, not just one waterfall. There will be, when the gorge was formed, there will be minimum few 100,000 waterfalls will be there, like this type of gorge. Yes, waterfall is involved in formation of this. Without that, it cannot form. India में Grand Canyon है on the Pennar River, I think in the Karnataka, Nandi Hills. Nandi Hills. हाँ, Mendikota, yes. What? I just forgot. What is the name? हाँ, yes. Nandi Hills से जो river आता है Pennar. Last year उन्होंने पूछा था. Last year में पूछा था. So that is a Grand Canyon of India. India has a 2-3 canyons, but not big. Northeast में एक दो river पे canyons है, but not as. बालपखरम National Park में एक canyon है. Okay, Balpakram National Park, there is also one canyon. Please see what is the river. Okay. So there are canyons, but they are not as grand as this. This is a true Grand Canyon. Okay, and so many tribes used to live there. You know, United States, what is there right now? Before that, entire United States was occupied by the tribes. There were 612 tribal nations in the United States. And when the white people came from the Britain, they all systematically, they killed those tribes, and right now very few tribes are there. New York City was taken from the tribe at the cost of 30 gold coins. Entire New York City, which is today. This tribes. You know, you go to the place called Tennessee. There is a place called Trail of Tears. It's the saddest place in the United States. It is said that United States government told the tribes, after they killed so many tribes and they defeated them, some of the tribes were there, they told them to leave this place and cross the river and go to another side, because here they said civilized people are living. Because they never used to consider the tribes as a human beings, consider them as animals, and they told them to leave them. So the practices of the tribes was that if somebody is died, they will not leave the dead body like that. Those tribes, if somebody dies there, they will make a monument there wherever they are living, and they will take care of the monument for generations. So if somebody dies, it is said so many of the elderly deceased, they died with hunger, and these tribal people carried them along with themselves for hundreds and thousands kilometers. No, the dead people, because they cannot leave them like that. So such a sad, in each and every family, somebody is dead and they are carrying hundreds of dead bodies, and they're traveling one place to another place. So that's why it is called as a Trail of Tears. That is there. So whatever places, you know, Dakota, Lakota, you have heard in United States. So these are the names of tribes. Red Indians. And their practices were so similar to like what Hindus do. Their sun, they used to worship the sun, they had sun dance, and they were living like, their culture was like full of festivals. Like in India, we have almost 365 days, we used to have some festival, ancient time. Every day used to be either festival, Ekadashi, Amavasya. You know, you see any moon-based calendar, if you see, some festival is marked. Though you don't celebrate it now, but some festival in small red, they will mark it. So it is said that ancient India was every day has some sort of festival, some sort of celebration used to be there. In some house, some festival is going on. So those tribal cultures were like that. Okay. So there are so many fights and all, so many scenarios. Those tribals are also very famous for their occult practices, medicinal mens and all those things. So many things are written there. Okay. So United States is full of these types of tribal massacre. One tribe they killed, that tribe, I forgot the name, I think Lakota or Dakota, someone, I don't remember. Their entire life was dependent upon the bison or a buffalo. So their entire culture was revolving around the buffalo. They'll eat the buffalo meat, they'll drink the buffalo milk, everything. So every year, they will take care of the breeding of the buffalo, and wild buffalo, they used to allow them to pass. So United States, they identify this tribe is dependent upon the buffalo. So systematically, they killed the buffaloes. As soon as the buffaloes were killed, this tribe also completely got vanished. And now the buffalo population is in the danger. Buffalo population is in danger, they're trying to save the buffaloes now. They're trying to increase the buffalo population now. So this is what United States or any Western, wherever the Western people went, wherever they settled, the history is full of violence and full of manipulation and full of so many things. In India, they tried to do, but somehow we survived. But it did not happen with Africa. Africa was such a great and prosperous nation full of tribes and animals and everything. But now Africa is in tatters. India has survived just because of the Indian culture. Just thanks to our culture that we have survived. However bad it is, definitely it was very bad things were there, but still we survived. All because of culture. Okay. So you will find the questions in the UPSC, why India survived. Okay, Egypt is gone. Mesopotamia is gone. Mayans are gone. All civilizations, thousands of civilizations came and gone. India is the only civilization standing firm on this earth. We have the oldest ancient city. Varanasi is the oldest living city in the world. Why it is surviving? Not just because of rivers. There were bigger rivers than the Ganga. It is because of the culture. Okay. So one of the Great Grand Canyon, one of the still very vibrant place, okay, in the USA. Okay, so canyon. What is it?
About George, also developed in highly porous and permeable rocks like limestone, where the rainwater seeps into the ground, leaving little scope for the valley to widen, sometimes formed due to pothole drilling mechanism.
See, this is a pothole drilling mechanism. I'll tell you, pothole it will come. So, in limestone also, it is saying that in the limestone also gorge can form. It is very easy for the gorge to be formed in the limestone because limestone gets dissolved in the water very quickly. So, it is very easy to create a gorge in the limestone. And pothole drilling mechanism will see that. Okay. So, pothole, see, this is the pothole. What is a pothole drilling mechanism? So, pothole means what? A very soft rock is there on the riverbed. Riverbed is full of soft rock. There is a small depression. In that small depression, angular rock comes and gets stuck. When angular rock comes and gets stuck because of the flow, at the bottom, force is very high, but water is moving very slow. So under the weight of the water, the rock spins inside the hole unless it has this angle, and the pothole keeps on widening and deepening, called as a pothole drilling mechanism. It becomes bigger and bigger and bigger, and it becomes pothole. The grinding action, it becomes pothole. So these are called as potholes. So there are very famous rivers, like there is a river called as Kukdi in Maharashtra. They have very big potholes. The entire human being can hide in the pothole. So gorges can also be formed through pothole drilling mechanism. Understanding? Okay. So these are the upper course features of the river. Now there is only one depositional feature in the upper course, which is called as the alluvial fan. Okay, alluvial fan. If you go to the Ladakh, you will see beautiful alluvial fans. Okay, so alluvial fans, they look like this. आपने Japanese fan देखे वो ऐसे ऐसे होते. So it is that fan, not your fan. Don't search this fan here, okay? Hand-held fan. So this is a fan-like structure. How it is formed? So when river comes at the foothill of the mountain, its kinetic energy is suddenly disturbed. Understanding? Kinetic energy is suddenly disturbed. When kinetic energy is reduced, when it is reduced, the bigger deposits are deposited suddenly without any gradation. Means generally gradation happens. First coarse deposit, then fine deposit, then final deposit. This does not happen. Suddenly it will be deposited in all haphazard manner, and it will obstruct its own course. And river will be converted, river stream will be distributed into many distributaries. Further, these distributaries, they will drop the content, and further they will get divided into sub-distributaries. Like this, so many distributaries will form, and finally the deposition of those distributaries, sub-distributaries will look like a fan. It is called as alluvial fan. So it is a full of heavy deposits, coarser deposits, and it forms on the slope. Understanding? So this is called as the alluvial fan. So alluvial fan, distributaries. So alluvial fan is the only, we can say, the depositional feature which is formed on the upper course of the river. Okay. The same depositional feature like an alluvial fan forms at the end of the river, at the lower course. That time it is called as a delta. But there is a difference between alluvial fan and delta. In delta, a triangular shape of landform forms. Here, deposits are deposited according to the grades, not in a haphazard manner. And it is full of organic content. So it is one of the most fertile region in the world, deltas. Many civilizations flourished in the deltas. Very fertile region. West Bengal, Bangladesh, full of delta. India's most prosperous region. That's why first Britishers came into West Bengal. This is a geographic reason. Why Britishers first settled into the West Bengal? What is the reason? Why they didn't settle in the Gujarat? Okay, the large British trading company which settled first was in the West Bengal. Definitely, they enter into the coastal areas, but they mostly settled first. They started extracting things mostly from the Bengalis. Yes, because Bengalis were the most prosperous people at that point of time. Okay. So, the upper course of the river has a alluvial fan, and the lower course has the same structure but of a different nature. You call it as a delta. Okay. Then now you have a middle course. You have different features in the middle course like meanders, oxbow lakes. So meander is a combination of erosional and depositional landform. So what is a meander? Now river is coming at the base of the mountain. Okay. So at the base of the mountain, what is happening? Speed is completely, slowly it is getting lost. So because of that, river is taking turns. A huge turns. Initially it was swinging. When it was swinging, vertical erosion was dominant. Now it is meandering. It is taking big turns. So when it meanders, lateral erosion is dominant and vertical erosion is less. Understanding? So when meandering starts, okay, now pay attention. When the meandering starts, inside the loop of this meander, what happens? Water is coming very fast. Faster current is coming and it is striking this part of the meander. So lot of erosion happens over here. Because water is striking in this end. Whatever eroded material is there, it is being transported to another bank and it is deposited here. So wherever erosion happens, it is known as cliff side slope because cliff forms here. And another side where deposition happens, it is called as slip of a slope. Here deposition is dominant and here erosion is dominant. So cliff side slope and slip of slope. So everywhere you have, see, cliff side slope is concave. Slip of slope is a convex. Okay, so you have these types of meanders. These are meanders of Amazon river. So big loops are there. See how big loops. Okay, these are the meanders of Amazon river. You see, after some time, these two meanders will merge with each other. See, here it will keep on eroding this region. Slowly it will merge with the river here. And this loop will be cut off from the main river. And it will be a lake will be formed, which will be called as Oxbow Lake. Understanding this? Okay. So Oxbow Lake will be formed in this way. Okay. So Oxbow lakes can be formed in the middle course or lower course, anywhere. Okay. So let us see the lower course of the river, where Oxbow lakes are also formed and flood plains. Now lower course is a full of depositional feature. One of the main depositional feature is a flood plain. So what is a flood plain? Flood plain means when river is flooded, the water crosses the bank and spreads few 100 kilometers around bank. And it remains there for few few weeks. So you know when the river is coming with lot of sediments, so this flood spreads water in surrounding area. So these fertile sediments get settled in the surrounding areas. And these fertile sediments which get settled in the surrounding area, after flood recedes, it looks like a plain, which is called as a flood plain. So you can see this is a flood plain like this. So every year, the soil is renewed in the floodplain because every year flood is going to come and it is going to bring new deposits. So every year it is replenished. You call it as a renewed floodplain. That's why they are the most fertile regions in the world. The plains around the river, Ganga plain, Yamuna plain, you say, they are the most fertile regions in the world. Another thing happens when river floods. Okay, here it is called as a natural levees. What happens when river floods? Coarser deposits set on the banks of the river. When flood recedes, the water goes on the main channel and this coarser deposit looks like a bund to the river. Can you see this? They are called as the natural levees. Understanding? If we have seen, everybody might have seen these natural levees. So they are the result of flood. Understood? Okay. Then you have Oxbow Lake. As I told you, when the meander loop gets cut off because of the cliffside slope is eroding continuously one loop. Okay. The loop gets cut off and river channel joins each other and the loop gets separated from the main river. So this is called as Oxbow Lake. It looks like this. So this is Oxbow Lake. Dull Lake, it is said that's Oxbow Lake of Jhelum. Dull Lake, Ular Lake, they say it is Oxbow Lake of Jhelum. Okay, so there are many Oxbow lakes in Himalayas. Okay. So Oxbow Lake is one of the important middle course or lower course structure. Okay. Then at the lower course you have river mouth. Okay, river is meeting the ocean, you have river mouth. Then you have a river delta. So as I told you, on the lower course, river speed is very low, very low, because it has come to the sea level now. So speed is very low, so all the finer deposits started depositing nearby areas. So river obstructs, because of this deposition, river obstructs its own path. It leads to the formation of distributaries. And delta forms. So India has so many deltas, famous deltas. We have Ganga Delta, Krishna Delta, Godavari Delta, Mahanadi Delta. Okay, so many deltas we have, full of deltas. Okay, so river delta is one of the most fertile regions. So deltas of various types: bird foot delta, low bed delta, arcuate delta. So many types of deltas are there. So I have given you in the notes. उसको एक बार पढ़ लेना. Lower course में delta is in the lower course. Okay, so types of deltas and the reason for the delta formation also I have given. Sometimes river water is heavier than the sea water. Sometimes sea water is lighter than the river water, or sometimes both are of equal density. Depending upon that, different deltas are formed. If river water is too lighter than the sea water, then the sediments float inside the oceanic water, inside the ocean, and say bird foot delta forms. So this is a Ganga delta. This is a lobate kind of delta, lobate shaped delta or arcuate delta. Okay, so they are very important from prelim point of view. In India, mostly deltas are arcuate shaped. Ganga delta is very big delta. It includes Bangladesh. So it can be also called as a lobate shaped delta. You can see different lobes. Okay, so you have a lobate shaped delta or arcuate shaped delta. When Godavari, Krishna, Kaveri, they also have arcuate shaped delta, like an arc. Mississippi River in the USA has a bird foot type of delta. Okay, then you have estuarine deltas, where estuary means, okay, at a particular level oceanic water meets with the river water and brackish water ecosystem is formed, which is called as the estuary. So it's a brackish water. I think the salinity is 27 ppts of the brackish water. Okay, upper limit is 27 ppts. So these are the different types of delta. So major Indian deltas you can see: Ganga arcuate, okay, Mahanadi, it is a triple delta, it's also arcuate, Godavari is also arcuate. So these are the different types of deltas. Arcuate. Ganga delta is arcuate delta, or you can call it as a lobate delta as well, if you want. Lobate shaped delta or lobe shaped delta. Okay. Understood, everyone? Alluvial fan will be in upper course. Understood, everyone? Any doubt? Okay. Guys want break? No? See, don't think about छोड़ देंगे, okay? टाइम से पहले नहीं छोड़ूंगा मैं, नहीं तो फिर कंप्लीट नहीं होगा. If time there, we'll start it. Time is there. Okay. Also, we have to do mapping also today. Some mapping. You don't want mapping? Okay. Take 10 minutes break and come back. मेंस के लिए बस आंसर राइटिंग का प्रैक्टिस शुरू करो. आंसर राइटिंग थोड़ा कंसेप्चुअल और करंट में थोड़ा सा कैसे लिंक करना है. जैन से मोस्टली अगर फर्स्ट टाइम अगर आप कर रहे हो तो प्रीलिम्स का फोकस विल बी वेरी हेल्पफुल. ओके, so first attempt, agar if it is not your first attempt, see if you have given 2 attempts before, you have studied everything before, then you can start February end March. इस बार प्रीलिम आई थिंक इन द मई में ही है ना. मार्च, अप्रैल और मई 3 महीने प्रीलिम के लिए बहुत होते. If you have given 2 prelims before, but see prelim again, see again, अच्छा कोई चाय वगैरह पीना चाहता है? नहीं, पी के आ गए. अच्छा कोई बात. पता नहीं होगा.
यहाँ पे भी एंट्रोपी स्टूडेंट बैठे हैं.
एंथ्रो ऑप्शनल के बच्चे सब. लेवल अप तो अभी बहुत बड़ा हो गया यार. अभी तो फाउंडेशन वगैरह अभी शुरू नहीं किया इन्होंने. इट वाज द ओनली कोचिंग इन द लॉकडाउन व्हिच वाज एक्चुअली रनिंग विदाउट एनी क्लासरूम. सब कुछ होगा तो इनको भी दे देना. कुछ होगा स्नैक्स वगैरह तो इनको भी दे देना. किसी को चाय वगैरह चाहिए? पी के आ गए चाय? तो ब्रेक में तुम लोग क्या मतलब चाय शुरू करें? आई डोंट नो हु इज देयर ऑनलाइन, मुझे पता भी नहीं. ऑनलाइन स्टूडेंट्स, आई होप यू आर देयर. आई एम सो सॉरी टुडे, since the app is not there, okay, I am not able to see what your questions are. YouTube live. आज ही चल रहा है YouTube live. ओके हाँ हाँ हाँ, स्विच इज ऑन. यूट्यूब लाइव पे कितने लोग दिख रहे हैं? 11 पीपल है. ओके, 11 people are watching. Okay, people are YouTube live there. If you are watching live, you can post your questions in the comment section if you have. Live chat is there. Okay, so Samakshi, will gorge in India eventually form canyon? Okay, Samakshi, not necessary that it will form any canyon or something like that. Okay, canyon formation is very long process. One of the criteria for the canyon formation is that it should have a horizontally bedded rocks. Multiple layers of horizontally bedded rock. That's why you have a great grand canyon. Okay, okay, so let us move towards the wind landforms or aeolian landforms. So see these landform names, if you see, they are very, very weird names. Zeogen, Yardang, this and that. Okay, the landforms are very simple, but names are either German, French, so that's what it makes a little difficult. So UPSC plays on this कि चलो ये तो बच्चे इग्नोर करेंगे. जनरल टेंडेंसी ऑफ मोस्ट ऑफ द कैंडिडेट, चलो बाद में करते हैं, इट्स वियर्ड, विल सी इट लेटर. ओके, yes. So this I have given you at one place. Even if you don't know in detail about each and every landform, at least you should know the names of these landforms. Oh, this is the wind landform, this is the water landform, this is the glacial landform. That much at least you should know. At least if you know what is it, that's the best. Okay, so wind has again erosional landform and depositional landform. First important erosional landform of the wind is a blowout or deflation basin. This is a place where this oasis starts getting formed. You heard about oasis. Okay, so oases are formed over here. Okay, so what is a blowout or deflation basins? So because of the heavy winds in the desert, sand starts flying from one place to another place, starts shifting from one place to another place. So you know desert is full of sand till the great depth. So till how much time or till how much deep sand will keep on shifting from that place? So until and unless it finds out the water table. So once the water table reaches, then the shifting of sand stops. But that area, it looks like a depression. But the depression has happened because the sand is being blown by the wind. So this is called as a blowout or deflation basin. Okay. Then you have this type of rock called as a mushroom rock. Okay. This is again hard and soft rock. So at the base you have a soft rock, at the top you have a hard rock. So at the base, rock is eroded more compared to the top. So this is called as a table and pedestal. Table rock, it is also called as, or it is also called as a mushroom rock. Okay. So it is called, in Sahara desert is called Gara. In German language it is called as a Pilsfelsen. तो बस इसको नाम या थोड़ा याद रखो. ठीक है, मैंने आपको नोट्स में दिए हैं, इसको स्टार मार्क करके रखो क्योंकि एग्जाम से पहले पढ़ना बस, या फिर जो भी सिंबल आप देते हो कि एग्जाम से पहले, तो उसका एक एट द एंड ऑफ द नोट्स आपने एक लिस्ट बना के रखो कि ये पेज पे ये है, एग्जाम से पहले पढ़ना है. बस एक दिन या 2 दिन पहले उसको जस्ट गो थ्रू दैट. Even you get 2 questions, that is a big thing. Okay. Then Inselberg or Monadnocks. Okay. So this is the Inselberg. You can see this is a single rock standing there. Okay. It is called as a Monadnock. Mono means one. So single rock is standing over there in the desert. Okay. This can also be a lava plug. We have seen the lava plug. Okay. This can be a lava plug as well. This is not a lava plug. This can be a lava plug. So single rock standing in the desert, it's called as a Monadnock. And German they call it as a Bonhart. Okay. So then this is a French word. Next landform, Demoiselles. This is also canyon in the USA. I forgot its name. Okay. So very famous canyon in the USA, where it looks like Demoiselle is a French word. Demoiselle, it's mademoiselle. It's coming from mademoiselle. Mademoiselle means young lady. Okay. So demoiselle means the person felt imagining like a young lady standing with the hat. That's why this landform is calling as a demoiselles. So this is also a place in the USA. It's a canyon. I forgot the name. So it's looking like a people are standing over here. Looks like a people are standing in there talking to each other or something like that. Okay. So this is very, very famous. It's the only place in the US. You know, US has such kind of places. Okay. So the top rock is, let us say, more resistant and bottom rock is less resistant. So bottom rock is eroded very fast. Okay. So they are also called as the chimneys. You know, tractor has a chimney or a factory has a chimneys like this. So they are called as the chimneys. What? So top is little broad, you can see. And bottom, actually it was a big rock, so it has become slender. So bottom is soft, that's why it is slender. Okay. Top का जो rock है थोड़ा सा बड़ा है. Yes, it is all wind erosion. Okay. Then next we have a Zeugen. It looks like, I don't have an image of that. It looks like an ink pot. Landform looks like an ink pot. Okay. So it's called Zeugen. Then you have a Yardang, or it's called coxcomb. So here you see this Yardang. It has a vertically placed hard and soft rocks. So vertically placed hard and soft rocks you have. So because of that, differential erosion is there. And the road, the gap between them is called as a caravan. So it is looking like a comb. The one geographer who has named it, it is looking like a comb. Okay, so it is also called as Yardang. Then you have a Dracanters. Dracanter means a triangular rock is formed because of the wind erosion. They are called as a Dracanters. Okay. Then again you have a wind windows, wind bridges. Okay, they are all wind landforms. Erosion happened because of the wind. Soft rock is gone and hard rock has remained. Okay, understood? Okay. So these are the erosional landforms. Then you have a depositional landforms. Depositional landforms are mostly in the form of desert depositional landforms, in the form of sand dunes, ripple marks. You have a horizontal dunes, vertical dunes, barchans, okay, reverse barchans. So many types of sand dunes are there. Then desert also have a alluvial landform of its own. Then desert में भी कभी-कभी बारिश होती है, थोड़ी बहुत बारिश हो ही जाती है desert में, तो उसके भी alluvial landforms, fluvial landform desert में भी है. Okay, तो पहले हम aeolian landform. Aeolian means wind. Okay, so wind landform. So first is a ripple mark. So this ripple mark can be either longitudinal ripple marks or transverse ripple marks, depending upon which direction they have formed. Okay, what is the direction of wind? If it is formed parallel to the direction of wind, it is a longitudinal ripple. If it is formed perpendicular to the direction of the wind, transverse ripples. Okay, so the sand travels from one place to another place in the form of saltation. So we are going to see this process of saltation. Okay, see how sand travels. There are three ways through which it travels. Okay, so first way is through creep. These are the sand particles, small sand particles. They travel through creep. Second way of traveling, okay, this is a creep. Second way is a saltation, like a bouncing. Okay, this is called saltation. So sand particles, they bounce and they travel. Okay, this is called saltation. And third is a suspension. A very minute sand particles which can hold into the air, they travel through suspension. So creep, saltation and suspension. These are the three ways through which sand travels. And these dunes keep shifting. Ripple marks keep shifting. Ripple marks are formed in this way. So next type of dune is a longitudinal dune. So longitudinal dunes are formed to the direction parallel to the wind. So these dunes are formed in the direction parallel to the wind. So wind speed is not very high and sand supply is low. Because of that, parallel dunes are formed.
Wind supply.
Wind speed is not very high and sand supply is very less. Okay. So you see, these are the parallel dunes. So ancient traders in the desert, they used to travel through the road in between. Their caravans used to travel the road in between. So that's why the gap in between the dunes are known as caravans. Understanding? So this is called as a caravan. Okay, इसका और भी नाम है, रेग बोलते हैं, हमादा भी बोलते हैं इसको. Okay, जो बीच में गैप है, इसको कैरावैन्स, रेग्स, हमादास ये भी बोलते हैं. ठीक है, हाँ, उसको भी कैरावान नहीं बोलते. जिधर भी गैप है उसको भी कैरावान नहीं बोलते, क्योंकि वो कैरावान उधर से जाता था, उनका ऊंट लेके जो कैरावान था उससे ट्रैवल करता था. अंडरस्टैंडिंग? ओके. नेक्स्ट इज अ ट्रांसवर्स डून. Transverse dunes forms when sand supply is good. Okay, so it forms perpendicular to the direction of the wind. Okay, so sand supply is good. In this case, transverse dunes are formed. Okay, so they look like this, transverse dunes. Now, this transverse dunes, what happens? After some time, the ends of the transverse dunes, they start bending. And they bend. So when they bend, barchans are formed. Understanding? So they are the crescent shaped dunes. A special type of transverse dunes. They are called as a barchan. Okay. Then there are other types of dunes which are called as reverse barchans. So here, the horns of the barchans are showing the direction of the wind. In reverse barchan, horns of the barchans will be opposite to the direction of the wind. Understood? So you have barchans, you have reverse barchan, and so many things. So reverse barchan, or they are also called as a parabolic dunes. Okay, so these are the different types of dunes. Okay, so there are different types of these landforms which are there. Okay, another type of landform is, as I told you, there are fluvial landforms in the desert. So small rivers is there, or seasonal rivers are there. They create fluvial type of landform in the desert. So they are of different names. These are badland. I spoke about Chambal ravines. So these are Chambal ravines, badlands. In parabolic dune, the direction of the horn is opposite to the direction of the wind. That is the only. Same like normal crescent normal dune, but the direction of the horn is just opposite to the direction of the wind. That is the only thing. Okay, yes. So badland, I told you how it is formed. We have discussed gullies, ravines. They are called as the chambal ravines. Very difficult. See, कैसे पकड़ेगा पुलिस वाला किसी चोर को यहाँ पे अगर घुस गया तो. Okay. तो यहाँ पे नहीं, ऐसे कुछ कुछ स्पॉट्स है इंडिया में अभी भी जहाँ पे बहुत एक्टिव चोर होते हैं. अभी भी वो स्पॉट्स जो है बहुत पुराने टाइम से चलते आ रहे हैं, जहाँ की चोरी अभी भी लोग खत्म नहीं कर पाए. चंबल एक ऐसी जगह है कि कोई महाराष्ट्र से है तो है, इज एनीवन फ्रॉम महाराष्ट्र. ओके, so there is a place, region between Solapur, okay, which is called as Jat up to Kurduvadi. So it is a backwater of Ujni Dam. So it is a full of backwater and full of marshes and bogs. तो आज भी वहाँ पे चोरी होती है. मतलब जैसे ही जत स्टेशन आता है तो पुलिस वाले वहाँ पे आते, पैसेंजर्स को बोलते हैं कि दरवाजे खिड़की सब बंद करो. कुर्डुवाड़ी आता है तभी खुलते हैं, क्योंकि वहाँ पे ऐसे ट्राइब्स है, वहाँ पे ऐसे चोर है, प्रोफेशनल मतलब जनरेशनल चोर है. दे आर नॉट टुडेज थीव्स, दे आर लाइक ग्रेट ग्रेट ग्रैंडफादर. इट्स लाइक प्रोफेशनल, यू नो. दीज आर द थीव्स. उनके खुद के भगवान होते हैं, चोरी चोरी सक्सेस देने वाले भगवान होते हैं, उनके डेइटीज होते हैं. So how they do it, like they will apply all oil on their body, और सब बॉडी पूरा काला काला और एकदम आएंगे रात को ऐसे ही खींच लेंगे पूरा तेल, पकड़ ही नहीं पाएगा पुलिस वाला. पुलिस गोली चलाएगा, कुछ करेगा, फिर वो बैक वाटर में भाग जाएंगे. बॉग्स एंड मार्शेस में उनका होता है, वो भाग जाएंगे. पुलिस कहाँ पे पकड़ेगी? यू नो, आवर पुलिस आर सो फिट, नो, everywhere police are so fit, so it's very difficult to go behind them. So still there are spots like this. The geography gives them advantage. Okay, they take the advantage of geography, and so Chambal is one of them. Still Chambal, some places very dacoits are there, thieves are there. It's very difficult to go. Poverty prone region. The Solapur region is also very poverty prone region. Okay. Ravines are small. So this is very small. See, this is very small. You can easily climb and you can easily come down in 5 minutes. Valleys are very deep, and valleys are huge.
What is behind the
Ravine same. See, little bit of, not too much of rainfall, not too less of rainfall. So because of that, a small ravines has been formed. अगर यहाँ पे बहुत ज़्यादा रेनफॉल हो जाएगा तो बहुत डीप वैली फॉर्म हो जाएगी, पूरा लद्दाख बन जाएगा. यहाँ पे लद्दाख में ऐसा ही है, सेम टोपोग्राफी इज देयर. वैलीज आर वेरी डीप, हिमालयस. Okay, so these are called as a badland. Okay, so you can see in the desert region, only in the rainy season, a small lakes are formed. Between two mountains, a small lake will be formed. It will be seasonal lake. It is called as a playa. And since the topography of the mountain is very loose topography, many alluvial forms are fans are formed at the base of the mountain. Many alluvial fans are formed, and these alluvial fans, they are adjacent to each other. Okay, so because of the adjacent alluvial fans, they are called as bajada. So this is a series of alluvial fans. Okay. See, we have seen in normal case you have only one alluvial fan. तो यहाँ पे desert region में soil is so loose, the amount of deposition which comes to the river is a huge. So because of that, all direction of the mountain, so many small rivulets are there, and so many alluvial fans are formed adjacent to each other. So this is a series of alluvial fans. They are all merged with each other. So they are called bajada. Between pediments means at the base of the mountain. Pediment. Playa means at the center of the, in between two mountains. See, this is a pediment. This is a pediment. And this is a playa. Playa is a small lake. River is coming and meeting at the center lake. See, pediments means यहाँ पे से mountain शुरू होता है. हिंदी में क्या बोलते हैं जहाँ से माउंटेन चढ़ना हम शुरू करते हैं? फुट हिल्स. हिंदी में क्या बोलते हैं? मतलब पैर समझ लो, माउंटेन का पैर. No, don't know the word. Okay. So at the base of the mountain to the lake, in between you have this bajada. Understood? Okay. So very simple landform, just they will be asked here and there. Understood everyone? Okay. So this is all about aeolian landform and fluvial landform. The last one is a glacial landform.
So underwater.
क्या? अंडरवाटर कौन सा लैंड? ओशनोग्राफी में देखेंगे. ओशनोग्राफी में देखेंगे. The karst topography you are asking. There are so many landforms. Okay. Both landforms are here. Okay. We're not required to do so much in detail. Since he has asked about karst topography, so karst is a region in Iran which is full of limestone underground. Okay, तो underground क्या होता है? Underground जो water होता है, that water dissolves that limestone within, and then like a lot of depressions are formed underground, and suddenly the land goes down because lot of caves are formed inside. So suddenly somewhere roof is collapsed and your home is underground. नहीं वो that's a different, that is in the cave, that's called as stalactites and stalagmites. So what happens in the caves, okay, when you have a lot of salt content in the water, okay, the water keeps dripping, and at the base of the at the roof of the cave where the water is keep dripping, salt starts accumulating. तो वहाँ पे धीरे धीरे salt accumulate हो के ऐसा ऐसा एक protruding एक स्ट्रक्चर बन जाता है. नीचे जहाँ पे पानी गिर रहा है वहाँ पे भी सूख के वहाँ पे भी सॉल्ट जो है वो अक्यूमुलेट होना शुरू होता है. तो नीचे से भी एक आता है, ऊपर से भी एक आता है, पानी में दोनों मर्ज हो जाता है. इट्स अ सॉल्ट स्ट्रक्चर. वट एवर सॉल्ट इज देयर इन द क्वांटिटी, दैट सॉल्ट कॉलम विल बी फॉर्म. So one is called as a stalactite, another called stalagmite. There are so many types of landforms. ठीक है. So now we'll see glacial land. हाँ, लोएस्ट भी आता है. बहुत सारे टाइप के लैंडफॉर्म्स है. अगर आपको एक दो एक्स्ट्रा इधर उधर कुछ मिल जाए तो आप पढ़ लेना. ठीक है. ओके, देयर आर सो मेनी. If I give you all the landforms, means the entire notebook will, notes can be filled with the landforms. Okay, so many. So we have given very few landforms which are important, which can be asked. Okay, next is a glacial. Okay, glacial landform. Glacial means, you know, penguins are there. So penguins are one of the important in South Pole, you know, Antarctica, they're full of penguins. Okay, so you might have seen those Ice Age movies. You see those Ice Age movies, they are very nice. Don't see them as a cartoon movies. Then from the UPSC point of view, you can see them. Okay, because they have shown a lot of continental drift and plate tectonics and so many Ice Age and woolly mammoths and so many animals which were extinct now. From that point of view, you can see that. Okay, so glacial landforms, if you see, there are various types of glacial landforms. Okay, so where glacier is born, that place is called as a corrie. See, slowly on the mountain side, you have a small valley, kind of a depression, where snowfall, because of the snowfall, a glacier is born. It is called as a corrie. So what happens over here? Then when it is formed, it starts moving. So this, like, the way it moves is like a rotational slip. It rotates like this. Okay. So what happens in the glacial? Because of the heavy weight of the glacial, bottom of the glacial heat is very high. From the top, because of the heavy weight. Okay. The soul of the glacial, they call it, is very hot. Temperature is very hot, so water is continuously melting from here. That's why river is born out of a glacier. So whatever water melts, it will come out in the form of river. That's why glacials are the source of river, we say. Okay. So because of the heavy weight and heavy temperature, it is also creating a friction with the rock below on the mountain. Understanding? Okay, and it starts eroding the bottom. The soil starts eroding the bottom. Understanding? So this is a birthplace of glacier. Okay, so glacial are of various types. So here you have a valley glacier on the top of the mountain. Then here you have continental ice sheets. Entire continent like Antarctica is full of glacier. Okay, so valley glacier, continental ice sheets. Then you have ice caps. Like North Pole is ice cap because ice is floating in the water. So you have ice cap. The South Pole is a continental glacier. Himalaya, you have a valley glacier. Okay, so you have different types of glacier. So in this glacier, if you see the process of erosion, the process of erosion is of different types. The movement of the glacier is different types. So forward movement of the glacier is called as the advancement of glacier. Glacier moves forward, called as advancement of glacier. Glacial moves backward or withdrawal of glacier is called retreat. Either it can happen because of the front is melting or glacier is going backward. Okay. Then because at the front, because of the temperature, the front part of the glacier is melting, which is called as the ablation. Okay. So these are the different movement of the glacier. But when the front part is melting, you'll feel like glacier is moving backward. Front part is melting because of temperature. Okay. So you can see here, simple thing. See how this front part is melting. Now glacier is moving forward. Okay, like this. नीचे भी पानी है ना तो definitely. Now it is moving backward. Front part is melting over here. Okay. हाँ ये retreat हो गया. Ablation. I think it will be there in your notes. Okay, you can write down. हाँ थोड़ा सा इधर उधर हुआ होगा वो. अभी इतना सारा है वो नोट्स में, ठीक है. थोड़ा इधर इधर हो जाएगा वो, थोड़ा सा एडजस्ट करना पड़ेगा. Ablation means destruction of glacial front due to it can be melting, mostly melting.
Or what is the difference between the ablation and retreat, sir?
See, retreat can be because glacier is moving backside or the front is melting. But the front is melting is because of ablation, and you are feeling that glacier is going down, backside is a retreat. Okay. So these are the different.
Not a movement, but it's a movement.
Yeah, in a sense, ablation is not a movement, but you will feel like glacier is moving backward. Okay. The front is melting. Okay. So glacial process of glacial erosion. Okay. So two ways it is, or let us say three ways it is doing the erosion. First is the plucking. Second is the abrasion. Now it is not ablation, abrasion. Or it is called, and third is polishing. So the way glacier erodes is like a sandpaper effect. Have you seen the sandpaper? आयन जब रस्ट हो जाता है या दीवार पे कलर निकालना होता है तो दे यूज अ सैंड पेपर. सो ये सो सेम वे ग्लेशियर जो है वो इरोड करता है. अब कैसे इरोड करता है, सैंड पेपर इफेक्ट कैसे आता है? ओके, सो सैंड पेपर, ग्लेशियर बिकम सैंड पेपर एट इट्स सोल और बॉटम बिकॉज ऑफ प्लकिंग. सो प्लकिंग कैसे होता है? जैसे मैंने आपको बोला कि एट द बॉटम टेम्परेचर इज वेरी हाई, weight is very high, and glacial is actually moving at the bottom. So when it is moving, what happens? It plucks the pieces of rocks. तो रॉक के जो पीसेस है वो प्लग किए जाते हैं ग्लेशियल के अंदर, लाइक दिस. So when glacial water, it erodes the rock and these pieces are plucked, and when glacial temperature goes down, they get stuck into the glacier. Okay, when they get stuck into the glacier, it is called as a plucking. Then glacier becomes sandpaper. It bottom becomes like a sandpaper. Now this sandpaper is going to move on the mountain. So how it will do the erosion? It will completely erode the cliff of the mountain. It will be looking like this, like cat has been scratched the mountain, a big cat. You know how cat scratches, you know? Have any cat at home? Okay, so just imagine its claws are like this and it will scratch like a tiger or lion, it will scratch like this. So it's like a big cat has scratched the mountains, it will look like this. So this process is called as abrasion. Okay, so यहाँ पे देखो अभी abrasion. See, now the sandpaper is moving and it's eroding. Okay, so this is abrasion, it will look like this. This is the after effect of abrasion. Getting it? Okay. So this is how glacial erodes, the process of abrasion, or it is also called as polishing. It's like a दीवार को polish करते हो. It's like not with a sandpaper. Okay, like that you are doing the polishing of the glacier. Okay. So plucking, this is the plucking, abrasion. Because of that, various landforms are formed. So there are different types of landforms, glacial landforms. Okay. So we have seen V-shaped valley. Glacier makes U-shaped valley. So bumps, U-shaped valleys, hanging valleys, cirque, nunatics, horns, tarns, fjords. These are the names of the glacial landform. You have to remember them. Okay. So cirque is the place where glacials are born. They are the depressions. Okay. So you can see these are different cirques. In one mountain, you have many cirques. You can have many cirques. Cirques have a wall from 3 sides, and one side is free. Okay. The boundary wall between two cirques is called as the arête. The boundary wall between two glaciers is called as arête. If a mountain has a many cirques around it, imagine a mountain, every side of the mountain has one cirque. Okay, then what will happen? Because of the erosion, there won't be any much kind of rock. Okay, so at the top only you will have a rock like a horn. So that is called as a horn. Okay, so here you can see this is a cirque. So here you have many cirques. Here all the sides of the mountains you have cirques. So top has become very sharp, protruding. It is called as a horn. You can see this. It is called as a horn. Cirque. Now, the important thing that glacier creates is a U-shaped valley and not V-shaped valley. River water creates V-shaped valley. Why river water creates V-shaped valley? Because it is fluid. It can adjust itself according to topography. That's why V-shaped valley. But the glacier or ice is more stubborn than the water. It will not change its shape because the land shape has changed. So whatever come into its way, it will just demolish that or erode that, and out of that it will create U-shaped valley. You can see this is U-shaped valley. When glacial erodes, it creates U-shaped valley, whereas normal water creates V-shaped valley. See, this is a glacier created U-shaped valley.
Hanging valley, yes. Heights valley.
No, we'll see that hanging valley. We'll see. See, this is a U-shaped valley here. Glacier is creating U-shaped valley, but glacier is melting over here, and water is coming over here. Water is creating V-shaped valley after that. So both types of valleys are there. Okay. Then you have a hanging valley. So what is a hanging valley? So you have a main glacial valley, and above that you also have a small valley. See, this is a mountain top somewhere here. It has a main glacial valley, and in between a small glacier was there. It has also made a valley out of a mountain side. So this is called as a hanging valley. You'll see that many places you'll see. Even normal water also creates hanging valley sometimes. Normal river. Okay. So hanging valleys there, main glacial valley, hanging valley is one of the features. So you can see over here, this is a main glacial valley and this is a hanging valley. Okay, so this is the main glacial valley and hanging valley. So in this diagram, you can see all the, I think it is there in your notes. You can see all the landforms of the glacier. See, यहाँ पे क्या important है? Cirque or okay. Truncated spurs. Okay, truncated spurs. We had seen the spurs. So in case of water erosion, that spur is possible only because water is flowing. So spur has a protruding ends. We call it the fingers. But here, because glacial will not adjust itself according to the topography, so it will truncate the front ends of the spurs. It will erode the ends of, all the truncated spurs are there, its ends will be eroded by the glacier. So it is called as a truncated spurs and not normal spur, interlocking spur. हाँ तो interlocking spur नहीं होगा, interlocking है. Yes. So you don't have interlocking spurs. You have a truncated spurs. Understanding? Okay. So here in this diagram you will see all the landforms in one go.
Yes, sir. Truncated spurs here.
कहाँ पे? हाँ, these here you have truncated spurs. Yes. है ना, ये truncated spurs है. Fjord is a type of glacial lake. Okay, so you have so many types of glacial lake. Tarn, a glacial completely melt हो जाता है. चलो समर में मेल्ट हो गया, तो जहाँ पे ग्लेशियर था, सिर्क के आजू बाजू में एक लेक बनेगा, इसको टान बोलेंगे. ठीक है. देन न्यूनाटिक्स, कभी कभी क्या होता है, माउंटेन टॉप जो होते हैं वहां पे ग्लेशियर नहीं होता है, बट अराउंड दोज माउंटेन टॉप्स इज कंप्लीटली फिल्ड विद द glacial. So these black mountain tops, they are called as the nunatics. Understood? Tarn is a lake. Fjord is also a lake. At the bottom of the mountain where glacier is, you'll have a lake called a fjord. हिमालयज में आपको ये बहुत मिलेंगे, ठीक है. हिमालयज में इफ यू गो हिमाचल प्रदेश, उत्तराखंड, एनीबडी फ्रॉम हिमाचल प्रदेश, उत्तराखंड, if you go there you'll see so many lakes like this, tarns and fjords. सी ग्लेशियल का पानी मेल्ट होके जब नीचे आता है तो ये फ्योर्ड बन जाता है, बट ग्लेशियल खुद का खुद मेल्ट हो गया ऊपर ही सारा समर में. तो जहां पे ग्लेशियल था वहां पे कुछ तो पानी बचेगा, लेक रहेगा, दैट इज अ टार. डन.
rock basin at the floor of the pit. Rock basin at the floor of the pit.
What? So that is a tarn. So वो कहाँ पे लिखा है? रॉक बेसिन किसके डेफिनेशन के आगे लिखा? टान के आगे लिखा. तो जो सिर्क का बेसिन था ना, तो वहां पे पानी बचेगा ना, उसको टान बोलेंगे. सी यहाँ पे सिर्क था, मेल्ट हो गया सारा, पानी चला गया, थोड़ा सा पानी पीछे रह गया, लेक रह गया, फ्लोर ऑफ द टान. So this is floor of the cirque called tarn. ठीक है, समझ में आ गया? So this is all erosional features. Okay. Now there are depositional feature. अभी सारा निकाल तो लिया है, डिपोजिशन भी होना पड़ेगा कहीं पे. तो हमने वेगनर के टाइम पे देखा, he has spoken about glacial till. तो जो प्लकिंग किया है, ग्लेशियल आगे जाके कहीं पे डिपॉजिट तो करेगा. अच्छा, ग्लेशियल में दो टाइप का इरोजन होता है. ग्लेशियल खुद इरोड करता है, दूसरा ग्लेशियल के नीचे से पानी भी निकलता है, रिवर निकलता है छोटा सा, वो भी आगे जाके रिवर इरोड करेगा. तो दोनों टाइप के इरोजन साइमल्टेनियसली चालू रहते हैं ग्लेशियर. ओके. So you have so many depositional features in case of glacier. Okay. So depositional feature or deposited material of the glacial in general is called as glacial drift. So डायरेक्टली आइस जो डिपॉजिट करता है इसे ग्लेशियल टिल बोलते हैं, और टिलाइट डिपॉजिट, थिक टिलाइट डिपॉजिट जो वेगनर ने बोला है. और जो पानी है, so that will deposit its own deposition. It is called as fluoglacial deposits. Fluoglacial deposits. Fluoglacial, whatever it is. Okay. So it is called as a fluoglacial deposit. Okay. So two types of glacial deposits. So there are so many names: eskers, drumlines. तो आप एक बार देख लेना, ठीक है. आउटवॉश प्लेन्स, केटल होल्स, केम्स. मोरेन्स थोड़ा इंपॉर्टेंट है, मैं आपको बताता हूँ. ओके. So this is a ridge-like deposits arranged, or it is a glacial till arranged in the form of ridge-like deposits. So generally ग्लेशियल का मोस्टली जो वेट होता है वो साइड्स में और सेंटर में ज्यादा ओके अकुमुलेट होता है. तो साइड्स में क्या होता है, जो भी उसने प्लकिंग वगैरह किया है, सो आफ्टर द ग्लेशियल इज गॉन और इट इज मेल्टेड, ऑल द डिपॉजिट्स आर डिपॉजिटेड ऑन द साइड्स. सो इन द लाइन और इन द लाइन इन अनऑर्डरली मैनर. देखो ग्लेशियल के अंदर स्टक हुआ था, ग्लेशियल मेल्ट हो गया है, सारा का सारा वैसे ही नीचे गिर जाएगा विदाउट एनी प्रॉपर अरेंजमेंट. सो दैट इज कॉल्ड एज अ मोरेन. और ग्लेशियल टिल, इसको एक ग्लेशियल टिल बोलते हैं, ठीक है. सो ग्लेशियल डिपॉजिट्स कॉल्ड एज अ ग्लेशियर मोरेन. तो मोरेन है, ड्रमलाइन है, तो आई हैव गिवन यू ग्लेशियो फ्यूएल डिपॉजिट्स भी दो चार दिए हैं, तो उतना थोड़ा सा पढ़ लेना, ठीक है. केटल होल्स, केम्स, तो अभी मैं एक एक एक्सप्लेन नहीं करता हूँ ये, ठीक है। सो वेरी सिंपल टू रीड दैट, ओके। तो आज घर जाके बस एक बार देख लेना, ठीक है। सो यहाँ पे ये जियोमॉर्फोलॉजी खत्म हो जाता है यहाँ पे, ठीक है, ओके। एक बस ऑनशोर एंड ऑफशोर विंड का एक कंसेप्ट है, आपको पता है कि नहीं पता नहीं, बहुत लोगों को पता होगा, ओके। तो अगला टॉपिक क्लाइमेटोलॉजी होगा, तो उससे पहले ये ऑनशोर एंड ऑफशोर विंड समझ लो क्या है। तो ऑनशोर मतलब क्या, शोर मतलब क्या, तो ऑन शोर विंड मतलब क्या, किनारे की तरफ आने वाली विंड, फ्रॉम ओशन टुवर्ड्स शोर। ऑफ शोर मतलब क्या, किनारे से दूर जाने वाली विंड, तो फ्रॉम शोर टुवर्ड्स ओशन। So these are the two important concepts. Onshore wind, because always you will encounter this onshore in oceanography and climatology, onshore and offshore. Okay. So उसमें और भी कुछ कुछ दिया है मैंने, उसको थोड़ा पढ़ लेना, ओके, घर पे। और पीछे जो है कुछ क्वेश्चंस है, उसको आज आप कर सकते हो, ओके, ठीक है। हम थोड़ा सा अभी मैपिंग का देखते हैं, ठीक है। डेली विल सी दिस फॉर सम टाइम, ओके। सो समथिंग न्यू ऑल्सो फॉर यू गाइज, इंस्टेड ऑफ जस्ट theory and theory, ठीक है। So you can take out your atlas. प्लकिंग और एब्रेजन में, कि प्लकिंग का मतलब क्या, आप प्लग करते हो, निकाल लेते हो, यू प्लग द फ्रूट्स, मतलब क्या, निकाल लेते हो। एब्रेजन मतलब क्या, इट्स अ सम काइंड ऑफ फ्रिक्शन, ठीक है। जो प्लग किए हुए जो पत्थर होते हैं वो ग्लेशियर में स्टक हो जाते हैं बॉटम में, और वो बॉटम जो होता है नीचे रॉक के साथ फ्रिक्शन होता है, उसे एब्रेजन बोलते हैं। Understood everyone? Okay. So if you have some mapping, if you have made something separate notebook for mapping or something, write down. Okay. Open your atlas. Every day I'll give you 1 or 2 current affairs, whatever is going on. Current affair, probable current affair location in the mapping. Okay. So you can open it. So guys, see, current affairs mostly you take care. Static mapping I will take care, because what is probable static mapping that UPSC can ask, I'll tell you all the famous places, we'll write it down daily, okay. But whatever is current, you have to take care of it, okay. Whatever current affairs you are going to read, just you have to mark those places, 1 or 2 lines about them, okay. So one current I'll tell you today, write down. क्या हुआ, भूख लगी? चलो अभी थोड़े टाइम में हम छोड़ने ही वाले हैं, ठीक है, 15 मिनट, ओके। So write down first, it's a current affairs, okay. Donab region of eastern Ukraine. Donab or Donab, D-O-N, or Donbass, sorry, not Donbass. Donbass, D-O-N-B-A-S. Donbass, region of eastern Ukraine. So word Donbass means Donets Basin, D-O-N-E-T-S, Donets Basin, Donets, D-O-N-E-T-S, Donets Basin, D-O-N-E-T-S, Donets Basin. Donets Basin, it is an abbreviation for Donets Coal Basin. Donets Coal Basin. It was once known for its coal and steel manufacturing. It contains two provinces, Donetsk, D-O-N-E-T-S-K, Donetsk, N-E-T-S-K, Donetsk, and Luhansk, L-U-H-A-N-K-S, Luhansk, Donetsk and Luhansk, which border Russia. Borders Russia. Both of them borders Russia. L-U, Luhansk. Okay. Russia recognized the independence of self-proclaimed People's Republics of Donetsk and Luhansk. Donetsk and Luhansk. Okay, so it was in the news. So unilaterally, Russia has pronounced the independence of Donetsk and Luhansk. So understand, this is geopolitically very important. It is a important coal region. It's important for coal and steel production. See, Ukraine is always in the news. Whatever probable questions are there on the Ukraine, you write it down. Around which sea it is, what countries are around Ukraine, Russia, Crimea, annexation of Crimean Peninsula by Russia. What is the importance of Ukraine? Ukraine is also called as a wheat granary of the world. Okay, when Ukraine war started, there was a wheat shortage in the Europe because Ukraine supplies huge amount of wheat to the world. Okay, so huge shortage of wheat happened. So all probable things related to Ukraine are very important. Why it is called a wheat granary? Now, why it is called as wheat granary? Why wheat production is very high in the Ukraine? What is the reason? So because the temperature is very ideal, the climatic conditions are very ideal for the growth of the wheat. Okay, generally Europe produces lot of wheat. In that Ukraine produces more wheat because temperature conditions are very ideal for the production of wheat. So wheat जो है production बहुत कम हो गया and plus they stop exporting the wheat to the world. So all the things around Ukraine you should know. Recently some cities were attacked by the Russian forces. Okay, so you should know what are the cities that were attacked by the Russians. Okay, just mention those places in your notebook. This is one of the important reasons they can ask about this. Okay, recently it was in the news. Okay, so today I'll give you only one. Okay, current affairs thing. Okay, tomorrow I'll give you one more. Write down one more from India called as a Nada bait. Nada bait. N-A-D-A-B-E-T. Nada bait. B-E-T. Nada bait. नादा बेट और नाडा बेट, पता नहीं गुजराती लोग कैसे प्रोनाउंस करते हैं इसको. ठीक है, कौन कोई है गुजराती? आप कैसे प्रोनाउंस करते हो फिर इसको? So this is a village on India-Pakistan border. So नाड़ा बेट ही है ना, गुजरात में नाड़ियाड वगैरह सब जंक्शन है वहाँ. So this Nada bait here zero line borders exist between India and Pakistan. Zero line border. तो यहाँ पे जनरली फेंसेस नहीं होते, और फेंसिंग होता भी है तो बहुत ही माइल्ड फेंसिंग होता है. इट जस्ट लाइक कि इफ यू वांट टू क्रॉस द बॉर्डर वैसे चल के चले जाओ, ऐसे ऐसे बॉर्डर होता है. ठीक है, इट्स अ पार्ट ऑफ जीरो लाइन बॉर्डर. जैसे कि करतारपुर. ओके, करतारपुर को भी वो कर सकते हैं कि चल के तुम जा सकते हो, बॉर्डर क्रॉस कर सकते हो. ओके, so it is also there and it was recently in the news, Nada bit. Okay, so zero line border, and it played some role in India-Pakistan war, okay, in 1960s and 70s. Okay, so these are the two locations. थोड़ा सा और उसके बारे में जान लेना. ठीक है, नाडा बिट एक देता हूँ आपको, आज थोड़ा देख लेना इसके बारे में. बाकी थोड़ा स्टैटिक पोर्शन देखते हैं. ठीक है, स्टैटिक मैपिंग का थोड़ा देखते हैं. सो write down important lakes of India. Important lakes of India. तो वेरी फास्ट, देर आर सो मेनी लेक्स. तो इंपॉर्टेंट लेक्स के बारे में बस वन लाइनर इंपॉर्टेंट जो पॉइंट है मैं आपको देता हूँ. ठीक है, कहीं पे सॉल्ट वाटर है, कहीं पे ब्रैकिश वाटर है, कहीं पे बिगेस्ट है. सो दीज इंपॉर्टेंट कैरेक्टरिस्टिक्स आई गिव यू, जस्ट राइट डाउन. ओके, राइट डाउन अष्टमुडी लेक. Write down in short. Okay, Kollam district, Kerala. It has 8 branches. Kerala. It is a Ramsar site. Next, Chandratal. Chandratal, Himachal Pradesh, close to Kunzam Pass. Kunzam Pass. Kunzam, 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 Kunzam Pass. Chandra River originates. Ramsar site. Next, Surajtal. Again, Himachal Pradesh. Near Baralacha Pass. Baralacha Pass. Bhaga River originates. Bhaga. So Chandra and Bhaga River. So Chandra is originating at the Chandratal. Bhaga is originating at the Surajtal. So near Himachal Pradesh, place called Tandi. So near Tandi, this Chandra and Bhaga, they meet each other. And the new river forms, which is called a Chandrabhaga. Okay, near Tandi, Chandra and Bhaga, they meet each other. And the new river forms, which is called as a Chandrabhaga. This Chandrabhaga is called as a Chenab. as it enters into the Jammu Kashmir. It is called as a Chenab. Okay. जम्मू कश्मीर में. सूरज ताल रामसर नहीं है. ओके. Bhoj wetland situated in the Bhopal, Bhoj wetland situated in the Bhopal, recently as they put it into the Ramsar. Okay, it is also a Ramsar site. Bhoj wetland. On Ramsar website it is showing. So there is a list of Ramsar websites, okay. rsis.ramsar.org करके, तो वहाँ पे आपको सारा Ramsar website. You can check whether recently it is added or not. Okay, so it is also part of Ramsar. Next. Dal Lake. Located in the Srinagar. Oxbow Lake of the Jhelum River. Oxbow Lake of Jhelum River. Lake of Jhelum River. Originally, it was 115 square kilometer. Now only 16 square kilometer has remained. 115 square kilometer. Now only 16 square kilometer have remained. And future it may disappear. 16. Yes. बहुत. सेडिमेंटेशन और वहाँ पे जो टूरिस्ट एक्टिविटी, लोगों ने हाउस बोट बनाए हैं बहुत सारे, बहुत ज़्यादा सेडिमेंट हो रहा है, लोग उसमें भराव डाल के वहाँ पे घर बना रहे हैं. आप गए हो, कोई श्रीनगर गया है कभी? इफ यू गो देयर यू विल सी उसके लेक के अंदर ही मीना बाजार करके एक बड़ा मार्केट है लेक के अंदर. ओके, जो आप मतलब शिकारा बोट होता है उससे आप जा सकते हो. और लोगों ने मतलब वहाँ पे मतलब फैशन ही आ गया, वो लोगों के पास पैसा था बहुत, सैफरन और एप्पल बेच के लोगों ने वहाँ पे हाउस बोट बड़े बड़े मतलब बना दिए वहाँ पे. और वहाँ पे फ्लोटिंग गार्डन्स भी है, अंदर फ्लोटिंग फार्म्स है वहाँ पे. So so many things, encroachment and all this sedimentation has led to the. एंथ्रोपोजेनिक मोस्ट ऑफ द, अभी जो भी कहीं पे भी कुछ हो रहा है सारा एंथ्रोपोजेनिक रीजन से ही हो रहा है. स्लोली तो होता है बट इतना फास्ट नहीं होता है. ये तो ऑलमोस्ट 20, नॉट मोर देन 20-30 years.
ऐसा हो रहा है?
लद्दाख में बहुत सारा हो रहा है, लद्दाख में बहुत सारा हो रहा है. डेफिनेटली देयर आर सो मेनी लेक्स इन लद्दाख.
कोई लद्दाख का कोई एक लेक है सर, उसका
सो देखो इन्होंने ये लेक जो है वो रामसार में भी नहीं डाला. इतना इतना ये अंडर थ्रेट है, बट इट इज नॉट अंडर इन द रामसार. ओके, अष्टमुड़ी इज इन द रामसार. ओके, वो लिखा ना, अष्टमुड़ी लिख लिया. ओके, नेक्स्ट वन. सो ज़्यादा नहीं, 2-2 3-3 लाइन लिखो आप. ढेबर लेक. ढेबर लेक राजस्थान से है कोई? ढेबर लेक, उदयपुर. ओके, ढेबर लेक situated in the Udaipur, largest artificial lake in India. Built in 17th century by Raja Jai Singh by damming the Gomati river. Gomati river, damming Gomati river. 17th century by Raja Jai Singh. Damming the Gomati river. डैम बनाया वहाँ पे. गुरु डोंगमार, GURU, Guru DONGMAR, Guru Dongmar Lake. Guru Dongmar Lake, one of the highest altitude lakes in the world, in the state of Sikkim. One of the highest altitude lakes. Dongmar, DONGMAR, Dongmar. Altitude lakes in the world. Lies on the north side of Kanchenjunga mountain or range. Close to the India-China border. One of the sources of Tista River. Next, Tista River. Next, Hussain Sagar, artificial lake in Hyderabad, built on river Musi. Hussain Sagar. By built on river Musi. Koleru, largest freshwater lake in India, situated in Andhra. Between the deltas of Godavari and Krishna. Under Ramsar. Yes, under Ramsar. Only lake in Andhra which is under Ramsar. Next one, Loktak Lake. Loktak, largest freshwater lake in the northeast. Yes. Only floating island lake in the world. Only floating island lake in the world Yes, due to floating fumdies. Fumdies. Menmecho Lake, MEN-MECHO, Menmecho Lake. MEN-MECHO, Menmecho Lake, located in Sikkim near Jalipla Pass. Jalipla, one of the sources of Tista River. Jalipla Pass. Then Pangong Lake. Pangong, 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 situated in Ladakh. Closer to Changla Pass. Changla. कौन? Changla Pass. Pulicat Lake. Pulicat. Saltwater lake. So on India-China border, okay, Pangong Lake. Pulicat, second largest brackish water lake. Brackish water on the border of Andhra and Tamil Nadu. And the barrier island of Sriharikota, one of the rocket launching center. Separates the lake from Bay of Bengal. Bay of Bengal से. Rakas Lake. Rakas in Tibet, source of Satluj River. वही है बट उसको राकस बोलते हैं. See, it's like closer to Mansarovar Lake. See, if you see the Rakas and Mansarovar, they are like close to each other. In between, a small canal is joining, very small. शेषनाग नहीं, वो तो श्रीनगर में कहीं पे शेषनाग वगैरह. नहीं, वो दूसरा कहीं पे. आई थिंक वो शेषनाग लेक जो आप बोल रहे हैं ना, वो आई थिंक अमरनाथ के यहाँ पे कहीं पे. इतना मुझे पता है, मानसरोवर को नहीं. सोर्स ऑफ सतलज रिवर. Mansarovar is a, I think Mansarovar is a, sorry, Rakas is a saltwater lake. I think एक बार check करना. Rakas is a saltwater and Mansarovar is a freshwater. Small canal. It is like that. Now it is possible, you don't know how it is, but a small canal is joining them. And devotees, if you see, they don't take bath in Rakas lake. They take only bath in Mansarovar lake. Sambar Lake. SAM BHAR Sambar. Largest salt lake in India. Close to Jaipur. Close to Jaipur, okay. Sambar Lake, it's a Ramsar site. Ramsar site. सांभर लेक है यहाँ पे, कैसे? ओ, तो हो सकता है आपको पूछा जाए, थोड़ा सा देख लेना, ओके। वेम्बनाड लेक, लार्जेस्ट लेक इन केरला. वेम्बनाड. Famous for boat competition. Next is Rudrasagar Lake. Located in the Tripura. Ramsar site. Yes, Tripura. It's a Ramsar site.
So राजस्थान में कोई आपसे
हाँ. Ranthambore. Okay, wait. I am telling you. Pala wetland. और पलक दिल wetland और Pala wetland. Largest and biggest lake in Mizoram. Biggest lake in Mizoram. Write down. Falls under Indo-Burma Biodiversity Hotspot. Indo-Burma Biodiversity Hotspot. यहाँ पे पलक वाइल्ड लाइफ सेंचुरी भी है. तो नॉर्थ ईस्ट बहुत इंपॉर्टेंट है, याद रखो. वो वहाँ के लेक्स जो है वो सब इंपॉर्टेंट है, ये पूछा जाएगा आपको बहुत बार. ओके, एक लास्ट लिखो, लास्ट. दीपोर बिल. DIPORBIL. Dipor Bill. Bill means lake. Located in the Guwahati, Assam. Freshwater lake. Formed because of the small channel from Brahmaputra. From Brahmaputra. Ramsar site. Coming out from the Brahmaputra. Okay? Brahmaputra is very big river. ठीक है, इतना काफी है. ठीक है, आज के लिए इतना काफी है. So tomorrow we'll start with the climatology. Tomorrow most probably we'll finish the climatology, and most probably we can even start the oceanography and finish half of it. ठीक है.